Is cool. All right. Hello, everybody. Been a while. Been busy, and it's been hot over here. Finally have a little bit of an acceptably cool day to actually sit behind a desk and have my camera on. Yeah, we're back. Hopefully, everybody's doing well. And I'm going to have a little bit more of a look at where we are with XR Tools. The last week, I've been very busy with doing a bunch of rendering work. So I haven't actually touched XR Tools for over a week. So for me, it's also going to be remembering, all right, how far did we get? Where are we? What do we need to do next? So with that, we'll do a bit of a recap about what we were working on and how far it got. So I believe in the last stream, we were working on the hand tracking and especially the grabbing. We're having a lot of trouble with the way that I was doing physics with the hand. So I went down the step to a slightly simpler approach, but one that I actually think works pretty well now. The main difference in the way that it worked before and the way that it works right now is that when we pick up an object, we are actually applying the forces to the object that we've picked up. And there's some nice logic there for when you have a two-handed grab. The other thing that I've been working on is the finger posing part of it. So if we go, for instance, to our rigid box, I've got my grab points working again. I still have a few things to do around automatic grab points, but I'm concentrating on fixed grab points at the moment. So we'll see that there's some new options here. Oh, I can't make that bigger. So we have a new option called finger poses. That if I do show hand, you'll see that the hand's no longer straight, but the hand is actually grabbing the box. But you'll see that there's a second option here called open finger poses. Hey, Flamework Studio, how are you? Nice of you to join. And I'll just for fun, I'll just create one. So we just create a new poses object there. And you can see that for all the different fingers, I can set things. So if I leave that empty, it actually doesn't do anything. But if, for instance, I go onto the index finger and I enable that, and just leave the defaults for now, we find some test values here. So in this case, the index finger is always handled by the trigger. So I can simulate the trigger response here. And the trigger, as you press it on the controller, goes from 0 unpressed to 1 fully pressed. So by default, I'm showing this as fully pressed. We can thus see that our finger is in the position that is defined on the finger pose. But as I turn that back down, it actually moves. Now, the default option obviously is not what I want. So I'm just going to go and zero these out. That basically puts it to its default extended position. So now we can see that we're going from 0, completely extended, to slowly grabbing that box. Now, in the case of the box, I don't actually want that. I want the finger to just be on the box. That's why I didn't have an open one. So if I clear that out, I'm back to that. But imagine holding, for instance, a weapon and you have your finger on the trigger. You want to be able to specify, okay, what is the position when my trigger is pulled and what is my position when my finger is extended. So you can control that with the open and what originally in XR Tools 1 was called the close poses. So if we remove the close to sort of make it clear that, okay, if you just specify the finger poses, that is what the hand will be. And the other thing, of course, like I said, is, or like I showed, is you have to enable the fingers that you want to pose. So on the default pose, you'll see that all the fingers are enabled and all the fingers have settings. So just to quickly have a look at these settings, and we'll take the index finger again. So we have a number of properties here that we can control. And right now we're controlling them the sliders. I do want to, at some point, add some gizmos in that you can actually manipulate them in the 3D view. But for now, it is on the sliders. So with a spread, I can move my finger sort of like left to right. With the proximal curl, the proximal bone is the first bone in our finger. So here we can see that we move that bone inwards and outwards. Then our intermediate bone is that little bone over there. So we can move that one up and down. And then distal is our little tip of our finger. So we can move that with those. So those are the only inputs. Now, obviously, when you look at a finger, unless you break your finger, you can't move it like that. So that's why I've only done the curl. I haven't done anything that you can do there, except for obviously your base of your finger. You can move that. So that is why only those inputs exist. It kind of works like blend modes on animations, and possibly I will be using more in the background with that. But right now, this is just directly manipulating the bones. The other big thing that is now different is while this logic is built into a component, so if we look at hands poses, we can see that we have a finger pose modifier that we can add to a skeleton. That is if you want to use this directly, but in our case here, we are just using the collision hands scene, so that's inside of here. So that's a special node that has all the logic for showing the hand. There we go. That's our hand. So that actually creates the hand asset and adds all the modifiers to the stack, and also does the ghost hand thing. So we'll show that really quickly. We'll actually have this run for a moment. So obviously I do want to, for a minute, hide this. But if we actually run this project, go and be on screen, turn that one on. There we go. Turn that one on. So you guys should hopefully be able to see me. I should have both hands. I'm just going to go a little bit closer to the camera and not hit my microphone there. Sorry about that. So yeah, we got my hands. You can see that my fingers all move depending on how I'm really moving my fingers. So that's all logic that just comes out of the box in OpenXR, which is kind of cool. But I can now pick up my cube, and you can hopefully see that my cube is actually being held in that pose that we defined in that pose scene. And when I grab it with two hands, it's actually doing that for both hands. Now, this is the bit that's still missing. I should be able to rotate the box. I can rotate it around that axis. I can rotate it around that axis, but I can't do it like that. That's something you might actually add today. That might actually be a nice thing to do. But, you know, I can pick up that box really nicely. Same with this box. I can just pick it up, and, you know, as long as I hold my grip buttons, that all works. This one is, maybe you guys can see it. This one's a little heavier. So the weight simulation is not perfect just yet. Oh, I hit my computer there. I really need more space. There we go. So stacked all those together. I got one more heavy box here. So this one is a little bit, you know, yeah, you get a little bit of a feel that it's a little bit heavier, but I'm still not really happy about the weight feel there. There is definitely some room for improvement there, but the basics are there, so that's pretty cool. Okie dokie. All right. I hope that was all fairly visible on screen. That's the other thing that I want to do at some point. Not sure if we're going to do that today, but I actually want to have the ability to move the third-person camera so that I can actually position that. But right now it's in the fixed position. I did put it a little bit closer to the table so that you guys can actually see what I'm manipulating on the table. Before it was floating in distance a little bit. So yeah, that is a really quick demonstration of the logic that I have been working on. There's still plenty of things that I'm not happy about. Mainly when we are looking at the object over here, which is a cylinder with a number of smaller cylinders attached through joints. I can pick these up, and it will then manipulate the individual objects that I pick up, and it'll try and do its best to apply the constraints, but I found that that is still very rickety. But in the end, that wasn't even possible in XR Tools 1. Here, the basics are all there. I think it's really a limitation on how the physics engine applies this at this point. There's probably some constraints that we can do on the movement logic itself to improve that, but yeah, I'm not convinced that it's solvable to the extent that I want, except for really amping up the physics rates. And I think that's just the way that physics engines work, in the way that the object is manipulated, it'll then apply the constraints of all the joints and try to undo any movement that went too far. And it's just, with such direct manipulation as we're doing in XR, we're just overpowering what it can do in one calculation. If you update the physics rate, and something that we did in the stream a little while ago, where the steps are much smaller and the physics engine is way better capable of countering what you're doing and applying all the rules, all of a sudden things start to work. But obviously, there is a limit to what you can do about bumping up the physics rate. There's a point where it starts to become too taxing on the system. So I'm trying to build everything around the default physics rate, where we're matching the physics rate to the headset's refresh rate. And yeah, that's just a limitation that I've set for myself for now, simply because trying to go beyond that, we really start to get into the territory that we are pigeonholing us into certain situations that this will be good for. And for a lot of other people who want to build something simpler, they end up with something really overkill. So that's the constraint that I've set for myself right now. And I'm actually pretty happy where we are with the pickup logic. I've got a couple of experiments outside of my little test scene here where I'm picking up somewhat more complex objects, and it's starting to really work well. I have a gun scene somewhere where I can manipulate a gun, and eventually we'll have things like that in this demo as well once we start looking at the snap zones and things like that. But for now, that is for the future. All right. So I think we'll tackle that movement issue first, because that's kind of like an thing I've overlooked. And I kind of ran into that by accident the other day. So, that's actually something else that's really interesting to talk about, is I've cleaned this up a lot. So there's much more logic inside of the collision hands. I've even made the collision hands the default option for when we are using our standard character body rig. Again, everything is design component based, so if you don't want to use the built-in rigs that come with XR Tools, you can mix and match your own objects. So let's say that you want to do an MR application where you don't care about the locomotion things. You might just set up a scene where we just have an XR origin in the middle of the room. We have a camera attached, and we might still be using the hands to do manipulation of objects. You don't have to use this particular structure, but that is the one that we get by default. That used to have normal hands here, so just tracked hands without any additional logic. But I figured that most people who will be using XR Tools with the character body prefab, they will be using the collision hands approach. So that's why I've put them in default there. But yeah, the logic in here has been, there's a lot more things in there that I've kind of quote unquote hard coded or made normal, so that you have less need to know how to set things up. One of the bigger ones is actually the positioning. You'll see that we are actually nicely positioned on the palm of the hand right now. And it tries to, this is the difficulty with this. It tries to do that, but with tracking, we can't really trust where this location is, which is why we had a whole bunch of logic about repositioning things. And that's stuff that I have now moved into the object itself that you add in. Oh yeah, that was just for demoing. Probably can remove that. But a good example of that is the XR Tools pickup. That used to be a child of a bone attachment node. Now it's just normally on the hand. It's now always positioned at the start of the index metal carpal bone, because that is another thing that I found out is the palm bone and wrist bone in hand tracking is notoriously unreliable between runtimes. But seeing that the metacarpal bone of the middle finger, which runs from your wrist basically to the base of your index finger. Oh no, I'm using the middle finger, so I should point that. So from the base to the middle finger, that you don't move that bone, and that's fixed to your wrist motion. So I've used that as a reference, and I'm now placing the pickup logic at the start. But you'll see that the actual sphere of influence, so the sphere within which we detect if we can grab something, is actually centered on the palm. So that's all handled now inside of this. That's something that I'm really trying to build this in a way that someone doesn't need to know how things need to be positioned. They just add the components, and the components take care of themselves, and they place themselves in the right position. And you can see the same with the rigid box. And this was a really big problem in Godot or in Godot XR Tools 1 with people getting convinced. You can see that this is also referenced on that metal carpal bone and positioned as a result. Now, there is another problem here that we ran into is when you look at my hands are a certain size. Your hands might be bigger or smaller than mine. And when you're using, especially optical hand tracking, but even when you're using invert hand tracking, you are subject to the size of the hand, either of the player or the size of the hand that the runtime goes. And I was very surprised, for instance, to find out that the reference hand that Meta uses for their controls is actually a fairly small hand, while the reference hand that Steam uses is actually slightly larger than the hand model that we use here. So what we were seeing continuously was that even though we've got this nicely posed, if you have a bigger hand, you'll see that the fingers will move slightly forward and there'll be a gap. If you have a smaller hand, these fingers will actually move into the box. So I've added a bunch of logic in here, and that is optional logic. It's actually triggered by this key bone length property that will make sure that the size of the hand, regardless of the player's hand or the runtime's reference hand, the size of the hand stays the size of my mesh here. And that even works if you use your own mesh, because there is an option in here. Where is it? Appearance. There is an option in here to provide your own mesh and still use all the built-in logic. Well, if you want your player to play a giant who has giant hands, then obviously we want all the logic to apply properly to those giant hands. We don't suddenly want to scale those back to either what the player's hand size is or what the hand size is that we use as a reference in XR Tools. So there's some consideration there of what you're doing there. But if you're using this for an MR application where you're actually using your physical hands, you're going to want to turn that option off. You're going to want to scale your hand to the actual player's hand, and there you need to be careful that your mesh actually needs to support that. That's actually something that I still have want to properly do with this mesh, the mesh that is in XR Tools, the default mesh. That doesn't really react well when the player's hand is small. It kind of scrunches in. And that's something that I still want to do. Hey, SquarePeg, how are you doing? Sorry for reacting so late. I wanted to finish my line of thought here on the hand posing. So in the end, there is still some work to be done to make sure that all those locations are correct. The other thing that I really did that was really interesting in that key bone length is I'm actually, again, using the middle finger metal carpal bone as my reference so that everything is positioned correct. I'm only doing that when you pick something up. When you are actually hand tracking, everything will be referenced where the hand tracking is. But I found out, like I said, both the palm bone and the wrist bone are notoriously unreliable. For instance, I found out that the wrist bone on OpenXR is actually not pointing straight to the palm as it should be according to the specification. It is actually pointing to somewhere between your thumb and your index finger. And in lots of my videos, if you look back, you will actually see that this part of the hand is completely deformed. And that's because of that wrist bone that is oriented wrong. The palm bone for SteamVR is correct, if I remember correctly, but there's some weirdness there on some of the other platforms. So That's again, I'm using that middle finger metacarpal bone as my reference. That's really stable for tracking. Or I shouldn't still say stable. The tracking is stable. It's predictable in its location and orientation between runtimes because that's just how the bones in your hand work. But yeah, going backwards, it is now correcting some things. And that's also going to be important once we go to full body avatars, which is something that I want to do at some point, because I still want to be able to use all my collision hand logic. But instead of the collision hand drawing the hand, there's an option here where you can say, don't show the hand, but still have all your logic. The idea there is that the full body avatar will then work together with the collision hand logic to get the position of the wrist and the position of the fingers, but now apply that to the wrist and fingers of the avatar. Again, that is future music. That is something that I'm planning to work on. I've actually got someone on Discord asking me the other day, like, hey, I'm actually working on that stuff. Would you like me to help out? And to those things, I always say, yeah, please do. If someone else gets to it before me and is willing to adjust his approach to suggestions that I make, then yeah, anybody is more than welcome to help out, which will be real cool. I actually need to apply this debug color to our oh no, that's a pickup one. Yeah, I was wondering where that is. I think that actually the debug color is being used, but you can only see it in runtime because it actually makes all our bones red. Just suddenly remember that. It's one thing that I think is, I get why we've done it, but is annoying is you can't actually see the skeleton 3D gizmos and the, oh, sorry, no, not that one. That one you do see because that's the yellow stuff over here. No, the collision ones. Where are they? Here, collision object 3D. That is only applied to collision objects that are actually in your scene tree. Anything that is a child of something you include doesn't show it. It's a bit of a shame. I wish we could show the collision objects on the hand in the editor. Well, that's a nicety for another day. Okie dokie. Let's go and turn this guy. It actually doesn't matter if you leave this on, but the funny thing is if you leave that on, oh, let's save it. Save. You start seeing it on every object. So that's why I like to turn that off. This is a debug option, or an editor option, I should say. So for editor only. It will always hide that, obviously, in runtime. It's just a helper to let us position the hand. All right. So let's go look at some code. And then specifically, okay, so that's the other thing which is really interesting and where we're going to be working on soon. Let's actually make that a bit bigger for now. If we go to our physics process here. So this is the physics process that is positioning our hand in space. And it's checking a bunch of things. And then eventually, there's a lot to do here. That's actually... No, that's still here, but we might end up moving that. So this is a little bit of a check that if you are holding something and that holding something gets stuck and you pull your hand back too far at some point, that triggers a let go. There's a setting for that it actually does that. But yeah, no, eventually this is all the logic that actually positions the hand and does all the all these. I'm not sure if that to do is still valid. That positions the hand and applies the forces. In earlier streams, I was using pit controllers for that. Still using pit controllers in a few places, but here I've actually gone back to a calculation that I made a little while ago that looks at where the hand currently is and what the current velocity of the hand is, and it looks at where the hand should be according to the tracking, and it will calculate fairly accurately what the forces are, both movement and rotational, to move the hand from one position to the other. I eventually found out why that wasn't working when I did that before I went to the pit approach. In developing the pit approach, I found out the things that I was doing wrong. However, I'm still having issues. If my angular calculation isn't based on the rotation on the center of mass. If it goes off of it, especially if you apply the force off of center of mass, there's some weirdness that goes on. Well, not weirdness, it's actually just physics, but it makes it very hard to calculate the right amount. But the other thing is when it's compounded, and this I really got stuck on, where because you are, for the movement, if you apply the movement off center, that doesn't just do a movement, it also does a rotation. But you don't find out what that rotation is until the physics has been processed. So in my calculation about how much torque I need to apply, I never knew what that rotation was. And therefore, I could never calculate the proper torque. And that's why I've gone back through, okay, if I'm not holding something, I can work on the handle center of mass, which means that if I apply a force to move the hand, it's not going to rotate. So I can calculate the correct torque to move the hand into the location it should be. If the hand collides with anything, then obviously that force will be interrupted. And that's fine. That's exactly what we want. And it just means that the more off we are, the more stronger the force is that we're going to apply. And if we are broken up or intercept a static body, then nothing will happen. But if we push our hand against a rigid body, that's actually where the weight simulation works properly. So because it stopped, but I'm still calculating the full force needed for the hand to reach its current location or the track location, it will apply the right forces to those objects, which is really cool. But this is also why I then moved the grab logic. So you see that there's a lot of stuff removed here. Anybody who's followed my earlier streams. And there's no logic here anymore for two-handed or grabbed logic. That's now all moved into our pickup function. So in our pickup function, if our object is not picked up, obviously we don't do anything. Or actually, if our pickup function isn't holding an object, I should say. But as soon as we are, there's some logic in the pickup that will tell the collision hand, like, stop doing your thing, I'm taking over. And what we're doing here is actually figuring out, okay, with our object held by this hand, how do we need to move that object, or maybe held by two hands, how do we need to move that object so that it is in a position that's logical for where we're holding. Oops. I've also got a mode here whether the primary hand defines the movement, so that, let's say that again, you pick up a weapon, you want your prime hand, whether that's the right hand or the left hand, whether you're left-handed, you obviously grab the gun first with your left hand. Whatever hand is on the handle is going to define the position of the gun. But then your second hand, let's say that you're holding a rifle, your second hand is the thing that allows you to aim the gun. But there's another option, which we're using currently with the cubes, where we're simply saying no hand has priority here. So our positioning of the object is going to be an average of the two. So there's all the logic in here that takes care of that. So there's a bunch of logic here to make sure that we apply our parent velocity and torque. So this is for, hey, I'm actually moving through this space. I want to make sure that the object moves that far. So that's in there. But then here is the logic. Okay, like, how are we dealing with this? So we're going to say, okay, if we are the primary hand, we're going to check if we have another hand that's holding this. And we do some mixing and matching of that stuff. Here's that value that I was talking about, the pivot on primary. So making sure that the primary hand is doing its thing. We then apply our torque. And then here, there's a slight difference in the logic. If you're not pivoting a primary, we're doing that proportional move so that we're always nicely centered. But if we are, using the pivot on primary, we're only moving the primary hand. So the rotation is a mix, but the move is completely controlled by the primary hand, and the secondary hand doesn't move the object. We are assuming we've already done the move that we want. So that's how that works. Now, if we are not picking up a rigid body, but we are holding a static body, that's still a to-do. That's something that I also want to start implementing very soon. We're going to do the reverse. We're not going to try and move the static body, because we're not supposed to move static bodies. We're going to instead try to move the player so that you can climb up a wall or, you know, do monkey bars or things like that. So that's a topic for another stream, but that is coming. Hey viewer, how you going? Hey Punk Wreck Superman, yeah, glad to have you join. I hope you'll find it interesting. All right, so excuse me, got something stuck in my throat there. Let's grab some water. So the first bit here is handling the rotation. The second bit here is handling the move. So in our rotation, we need to do a little bit more work. What we're currently doing here is we're checking where our first hand is, we're checking where our second hand is, and we're doing that both ways. No, actually, we're only doing that on the primary. That's right. If we are the primary hand, we check the other hand. So this is also something that we don't want to double up. We only need to do that once. So when the secondary hands pick up this run, we just skip this logic. We only do it for one hand. But if we have another hand, we are going to look at the relative position between those two, and we are rotating our object accordingly. But again, we are missing the rotation around that vector. Excuse me. So we are going to have to check around that positioning vector how much we want to rotate that. Okay. And now I have to really look at this because it's a bit of a while ago since I last looked at this code. So I need to try to pick apart how does this work again. So we're working with our offsets because we need to know where our hands are offset towards. Because again, in our grab logic, we are looking at the positioning of the object itself. We will always place the hands and draw the hands relative to the object that we have got picked up. But we need to go back to that offset. So that is something that we are doing here. Got a vector between that, so we're checking what the vector is, and we're doing that in two spaces. We're doing that in the local space of our object, and we're doing that in the global space, and that's how we know how much we need to rotate our object from its natural position to the actual space in the world. For that, we have we have our destination vector, that is that vector around which we position, but we're now doing a cross between our starting vector and our destination vector so that we get a rotation angle to rotate it over. Okay, that's pretty cool. And that gives us a rotation basis to do that. And the other one is if we're doing pivot on primary. Oh yeah, we want to just adjust the origin, because else we are rotating around the center, but we want to rotate around the origin of what you call it? Oh, the primary hand. Yes, thank you, Baz. So that means that we actually want to add a little bit more here to actually rotate around. I guess around the cross rotates that. We want to rotate around the destination vector, I think. Yeah, because that is the vector that goes from one hand to the other. But now we need to figure out how much we need to rotate by. So let's go run our application one more time, because this is easier to talk about when we can actually visualize what's going on. Let's have a look at that. Alrighty. Come on, start tracking. There we go. Really need to be careful with my... Sorry guys, I'm going to move this a little bit further away so that I don't keep hitting it. So I hope my volume is still good. Let's just create slightly bigger ones. So, okay. So well, when I'm letting go, I can't point, but I'm grabbing one hand over here on the right, and then I'm grabbing the other hand over here. So that destination vector is the vector from the center of my primary hand to the center of my secondary hand through the object. That's what the destination vector is. So I'm taking that same vector as a source vector when my box is in its default position, and I'm just checking how much do I need to rotate my box to get to that. And obviously I'm calculating that from where my actual track position is, right? So now what I need to do is how much is it rotated around that primary thing. And I want to average that from the two hands. So I want to calculate an angle for this hand, and I want to calculate that angle from this hand. Okay, around that vector. How do we do that? Or do we just care? We probably only care about how much it rotated. Oh, yeah. We only care about how much it rotated around that angle. So we know what our vector is out of the palm of our hand. So we can easily calculate the rotation from the standard location. We can do the same for this, because that would eventually be the vector between our two hands. Is that true? Or am I mistaken? Because it wouldn't be true if I'm holding it like that. Or I would hold it like that. Do I still... No, I don't want it to have the rotation. Find the rotation of the hand around one single axis. How are we going to do that? So let's say if the vector isn't straight on the hand, but it's angled, and I'm rotating it still like that. How do I determine the rotation around that? Or am I just going to cheat it and just say, how much am I rotated against each hand? And then just balance it. That would probably work. Oh, accidentally took two. Yeah, I think I might just do it on each hand locally. That's a good one. All right, so now how do I know from which position do we do that? Because the thing is, the angle between what and what. That's a good one. That's a good one. Each hand locally might feel more natural. Yeah, that's what I'm thinking about. It just how do we determine that? And what reference do we do that? Because we could have a hand any way, shape, or form. Actually, seeing we have this. Okay, so what if I want to go back to my box. Where's my box? Where's me box? I just want to do the box because I can see the things here. So make you a bit bigger again. All right. Yeah. So All right. Okay. So we with that rotation matrix that is going to put our box in a certain place. So if I take my box like this. Oh yeah, I need to be careful that this might not be in the same angle. So I do need to look at our grab point. So what we need to do in here is that's our destination vector. That's a vector between the two, the center point between the two hands. Okay. We calculate our rotation matrix there, which positions our box, and with that, the hands, but it keeps it straight because there's no rotation around that vector. It is perpendicular to that vector. Okay, very cool. So now we move that there. So all we need to do is we need to take our orientation of our grab offset, and actually really all we need to take is the Z vector of that orientation, apply this to it so that we now have rotated. So whatever our Z is on our hand, we have now rotated that into where our box ends up and where our hand is on our box. And now we can compare that vector to what the actual vector on our tracked hand is. If we take the angle between those two, we know how much to rotate our box, but we want to have that angle perpendicular to that. Okay. I think we can do this with a couple of crosses. Yes, so we're not going to take the Z vector. We're actually going to take the Y vector, take the cross so that we can get a angle aligned Z vector with our destination. And we're going to take the angle of that. We do that for both hands, take the rotation of both hands, take the average, and that's how much we're going to extra rotate this. Okay, let's see if we can do that. Now calculate how much our tracked hands are rotated along our destination vector. So for that, we need to first calculate. Okay, was it our up vector? Did I close it again? Oh no, I still have it open. I just closed the view. So it's going to be in our Z. So yeah, we still have a green Y. We're actually, oh no, that's X. So yeah, we're actually interested in calculating that one X is aligned. So we're going to do some trickery here to make this easier to sort of visualize what we are doing. Why do you keep doing that? So we're going to cheat a little bit, but let's calculate it first. Primary dest up vector 3 is, stop it. Pop-ups are nice, but sometimes they're annoying. Okay, so that's going to be grab offset dot basis dot y, and we're going to multiply that with our target basis. Okay. That is a normalized vector. That should be good. So the thing that I wanted to do, I also want to do the secondary. And that's now going to be, hold on, other grab offset, yes. Okay. Right. So the next thing that we're going to do is, where are we? Because now we're going to fake it. We're going to do something which breaks all convention, but it's only for now, which is that on this pickup, I'm going to add a test vector. Okay, cool. I'm going to mark this as top level. We're going to see until we grab something that these vectors are just going to be floating around, which is going to be cool. I'm going to put them on both hands. They're just testing thingies so that I have them when I need them. And that's obviously immediately, yeah, why wouldn't it? Copy all that because, oh yeah. I was too quick in making it top level. Let's first put it in position. And now we're going to make it top level. There we go. Boom. All right, so we have this nice little white pointer thingies, vectors. So we're going to start visualizing, okay, where are they going to end up? All right. Because I want to see if they are actually pointing in the direction that I'm expecting them. They should be straight up on our little vector. The other thing that I actually really want to do, can I? No, we'll make another object to test that in a minute. Let's do one step at a time. So with that done, we now know that our pickup nodes, and I believe that here the other is the other pickup. So we can say for ourselves is, actually let's just use get node in this case, vector dots transform is going to be transform 3D. Do I need to calculate that differently? Okay, let's just do it like this: spaces, comma. This is going to be. No, I don't want it on the controller target, I think. And do we do it on the controller? It's going to be exact like that. All right, we're going to move this down here where we actually have now calculate our global target origin. Yeah, because that's just moving it there. Okay, yeah, I think that'll do. So let's just go, oops, let's just go and calculate that here. Let's global target origin. Yeah. That is going to be global target times that. So that should now, I think, be placed where we're expecting our hands to be. I hope. But now we want to do that. Actually, I can probably do looking at here. No, there should be a look at like this. And, ooh, that's going to be interesting because that is likely going to be up. Hey, it's up again. So let's do primary depth up. That's what we're going to look at. But we're going to make our up vector dot spaces dot z. So we're going to pretend that our up is actually outwards of our palm. All right. Because we don't really care about rotation. All right, let's see if we can do that for the other vector as well. But in this case, we need to do other.get vector transform is going to be all that. But now We want the other one. Where is the other grab set? All right. So now the big question is our vector going to be pointed in the wrong way because I made a mistake or because I made a different mistake? We'll see. We'll see. We'll see. We'll see. Let's go run this. All right. Let's go and have a look. All right. All right. So we can see that our vectors are just floating here because we're not positioning them unless we're holding something with two hands. So let's go, and actually you guys might not be able to see that because the camera is a bit far away, but there are some vectors floating in the air here. But now when I grab this with two hands, we can see, hope you guys can see that. We can see that we actually have the vectors in the right space. Now, no, they are not because they are pointing backwards. Huh. Okay. I must be making a... Yeah, it's not all that because that's actually the vector that I wanted to end up with. So did I make a... So we're getting the grab offsets basis Y. Hold on. No, that's not it. Okay. Is that... Why are we getting that vector? Huh. What am I doing wrong? What am I missing? No, yeah, no, I'll do all that. Is that because I'm doing that? Because primary, oh, I never made that secondary. Luckily, they were in the same orientation, but... And again, this is why I really want to position my grabs in two different orientations. All right, I'm gonna do one more little crazy thing. Again, this is bad stuff because this will break if we do it the wrong way around. But I'm gonna add a label to our right pickup. So we have to remember, we have to pick up with our right hand first, make sure that that is the primary, because I don't have a label on my left. But this will allow me to also do, that one I can just do. Let's put all the debug stuff over here. And also let's just say for tests, boom. That can just be node 3D. Go, and then we just say if tests. No, hold on. No, I don't care about that. That's overkill because this is a different node. Again, I don't care if it doesn't exist, then we get an error. Fine. 0.3.3F. 3. I really can't type today. There we go. Oh, come on, make some room. Bring this up. X, Y, Z. All right, so that's just going to print the oh, sorry, cat. I kicked you there. Come here, little cat. Why are you always sitting right in front of my feet? You know I always move my feet. Go, cat. Let's put something in front of it so that always goes all right. That's just going to be wherever our thing is. I don't really care about the orientation there. All right, let's try again. See if that does what I think it does. And then we can see whether we accidentally got onto a different axis or maybe something else. So we still have our thingies floating around there. Cool. 1, 2. Oh, that's way too big. All right. Well, that is definitely not pointing up. So our you guys can't see that it's the text is way too big. Oh, you can see it now. But yeah, my Y is actually pointing this way. That is really interesting. I wonder why. I need to figure that out because it doesn't make sense to me. So I am making a logic error somewhere. Because when we look at our grab offset, unless we're doing some sort of change here, because I'm expecting, because this is my grab point. So basically my grab offset is the location of that. Oh, no, it's not. What it is the location of that aligned with our metacarpal bone. So, okay, that's fine. If we go to our humanoid hand, and that's right, our metacarpal bones are Y aligned. So this is a weird thing in OpenGL, it's actually worse because in OpenGL, in OpenXR, our bones are actually Z aligned, and if you would take the bone structure and you would just import it as OpenXR gives you into, say, Blender, all these bones actually stick out to the palm direction. So we actually do a reorientation when we get the data from OpenXR into the orientation that we expect from a skeleton imported from Blender. So in Blender, they're probably also in a different direction. But in the end, for us, if we look at our, let's just add a bone attachment here. There we go. And let's go and pick our middle metacarpal. So that's the bone that we're using. Then you can see that that bone has the Y nicely pointed forward. Now, we had it pointing backwards, and that just has to do with the fact that, okay, I'm taking, well, actually, that's interesting. Why is it pointing backwards instead of forwards? Is that because I'm taking this as my up? No, that should just make a difference what direction the X is going to be in. If I add a vector here, oh yeah, that's right, because that is always pointing that. We need to reorientate that. I need to really run a script for that. I don't really want to do that. Okay, but my Y is pointing like that. So that is explaining why it is going somewhat in that direction. What's this all about? I'll have to do that later. Or actually in the middle of something. So Y is definitely that direction, but I don't know why we're getting it in the opposite direction. Because this is definitely, or do I do a rotation there? Maybe I do a rotation there. Okay, don't save. Let's go and have a look at how we are defining this. Again, it's a little while ago since I wrote this, so okay, Okay, let's have a look at how are we picked up by that. So we have our pickup. Now, oh, I'll probably get that earlier then. Do I? Oh yeah. Picked up. So it's an overrule here. If you have a custom pickup handler, you can override all this logic. I'm guessing that I am setting that in our pickup logic itself. But I can look at the other. So the other, I'm getting the other pickup, and then I'm getting grab offset. All right. Oh, which I've already calculated. How do I calculate grab offset? Because maybe that's my mistake here. In the end, it doesn't really matter. So I'm doing more here. Target. Now control the position and the object we picked up. Okay, so this might actually be in the controller space. Ooh. Huh. Yeah, I think that might be what I'm. Am I accidentally getting it on the palm position? That's the thing that I'm wondering right now. And is that the mistake that I'm making here? It might be. Okay, where's target offset coming from? Okay, let's target. Where's target offset coming from? Come on. Oh, target. Yeah. And target is my actual hand. Come on, stop doing that. Is my actual collision hand transform. All right. So that is a bit dangerous. Because again, I can't trust the palm transform that I'm getting from the runtime in so when we're looking at collision hands here, that's our rest orientation. So here our Y is pointing up. Cool. And when I am using, if I don't have access to hand tracking and I fall back to the default logic, I am using either the grip pose, which is actually like that, with the Y pointing like that, or I'm using the palm pose, which has the Y pointing upwards. So far, so good. But when I'm using hand tracking, I'm actually using the palm bone that is communicated. So in this case, again, if I go back to just opening up my inherited scene. Oh no, we don't have the palm bone in here because we skipped the palm bone in our skeleton, but we're still positioning the controller at that point at where the tracking tells us where the palm bone is. And like I said, the palm bone is relatively unreliable from one runtime by the other. Now, if we go into the specification, hang on for a second while I look that up. Here we go. So if we go here and we find our hand tracking ext, hand tracking, and we scroll down, where are you? There we go. So this is what, according to the specification, the hands need to be. And as I was talking about before, we actually have the Z bone pointing backwards and the Y bone pointing up. Now, as I mentioned, we actually rotate that 90 degrees because for our skeletons, we need the Y to be pointing along the line of the bone, and we have the Z pointing out of the palm. So when we go back to here, and we go to here, and we again add, I shouldn't have closed that scene, but I grab my little bone attachment and I grab that onto any bone that I want. We can see that we have the Z pointing out and the Y pointing forward and the Z pointing out of the palm side. And that's purely because we rotate it. So originally, when we get our tracking data, we're actually getting this, right? So that is what matches our specification. The Y pointing out of the hand, the Z pointing towards the origin of the bone, and the X pointing, well, in this case, to the right. So if we go here, we can see that is the orientation that we end up with, right? So that is the source, but like I said, we actually orientate that like this because that is what the palm structure needs to be. And that's why that is pointing outwards. Now, if everything follows the specification, our palm bone, which is the root of our tracking, which is the one that we position the controller on, should be this, but then rotated 90 degrees. So with the Y pointing there and the Z pointing up, and the same for the wrist, right? So again, the Y pointing that direction and the Z pointing up. Now, as you could see in what we were doing, because we were actually using that location, that's what we're dealing with right now. It's not. Palm bone is actually 180 degrees turned on how it should be according to the specification. I believe that on Meta, it is orientated in the right way, but it's not in the right position. And like I said, with the wrist on SteamVR, it's actually not pointing nicely backwards. It's actually pointing in that general direction. So for us, with the Y pointing forward, the Y is now for us pointing nicely between the metacarpal bone of the index finger and the metacarpal bone of the thumb, which is why when you look at earlier videos of mine, you can see that the base of the hand is deformed and is sideways. So there is now a risk in doing our orientation code based on that information. In theory, we should be all right because we've just proven that it does, we don't really care whether it points backwards or forwards. As long as it points in that plane, I'm happy. So if we, for fun, turn this off, and then I'll go to project settings, and I go to OpenXR, and I am turning hand tracking off just for now. We're going to turn that back on later. If we turn that off, we are now falling back on our, I think on our grip pose or on our, I don't know if I've done my 90 degrees fix yet, but here we go. We have our hands. So now you can see that our hands are, they're not doing our normal finger things, but it does react on the buttons. And on that, that's our fallback logic. Not as nice as what hand tracking does, But when I pick that up, still works. When I pick it up with both, I should have taken that label off. But, ooh, I don't know if you guys can see it. You can see the little horns on the bottom of the cube. So in this case, our vectors are pointing down. I was actually expecting them to point up. So that's already a really interesting thing in orientation. I want to get rid of that that label. That is way too big. Oh, now you guys can see it. Yep. So you can see here that those nice vectors are pointing down. So you can see how different that orientation is between the palm pose that I'm currently using and the hand tracking. But if they are always in that general plane, I don't really care. I can still do my calculation. It'll be that if there is a runtime out there that decides to rotate this palm so that the Y ends up pointing to the left or the right or something like that, or so out of the hand or out of the top of the hand, that's when we would get in trouble. I think we can risk that because that would be really, really bad if a runtime does that. I think it's always going to be in that plane. It's just, whichever way it directs. Now, I'm still surprised and confused why it's pointing down and not up. But I think that might have something to do with the way that we are applying this. Anyway, I'm going to leave these vectors in there for a minute. We might actually add some more, but I want to get rid of that that label because that is really annoying. Where are we? Process. Is it there? Yeah. No, it's not. Is it? This is process. All right, let's get rid of that before that gives an error. There we go. All right. So again, I'm not sure why it's pointing the wrong way, but in the end, why am I getting so many calls all of or messages all of a sudden? In the end, I don't care whether it's pointing one way or the other, as long as it points in the right plane. So let's go and duplicate this vector. I'm happy for that to be vector 2. But I'm going to make that one. Let's make that one blue. Cool. Let's for a minute turn off top level so that I can just go copy, paste. So in this case, it nicely goes where I want it to. Thank you very much. Make it top level again here as well. Make it top level again. So now I've got 2 vectors to play with, a white one and a blue one. And we're going to place this the way that our hand is actually oriented, but on that same location. All right. And then it's going to be a matter of calculating the angle between those two, because that should now be along our destination vector, because a cross between those two vectors will be, and we can actually see the sign of the two and flip it if we need to. That's kind of cool. All right. Okay. So, but let's start with seeing if we get the right vector, and I now need to think of because that was the other thing that I was struggling with. Is there's no guarantee that our grab is not swiveled, so we actually need to This is purely orientation. So we're actually going to want to have this to be a cross with this. Primary desktop. All right, we're going to do the same. And, you know, for us, this will just mean that it points into a different direction of what we just did. But it will align it with our vector. So if, again, you know, if our vector is like this and our hand is like this, it's possible that, you know, let's say that I'm holding the cube here and there instead of like that, then that vector is going to be like this. So I'm going to have my y vector actually point in. It's going to be ending up like that. So by doing a cross, I'm ending up doing it like that. And I know that my cross is now going to be perpendicular. So I'm going to go say normalized. There we go. I also want to have that normalized. And I'm going to get this normalized. And I'm going to say that needs to be the secondary. Okay, so that is going to be our, actually, this is not desktop. This is start up. And I want to do that here as well. Yep. And now I'm going to call it, because our destination is where we're going to be ending up. So boom, boom, boom. Destination. So now we're going to do the same with our controller target. And that is going to be our dest. So now we're going to make a dest. Probably should have copied that before renaming everything. Okay, but now we're going to go and take our controller target basis y and then cross that. And then it's this and this that we're going to compare, because those are going to be two vectors before, after on our destination vector. All right. Cool. Now we want to do the same thing here. Dest up. Okay, and that is now going to be our other controller target. And now here we're going to say vector 2 is going to be our primary dest up. And then here, vector 2 is going to be our secondary dest up. Okay. I think eventually we're going to do some of this. And hold on. I'm making a mistake here. This one is not rotating around that, because that is already in the right orientation. Okay. Cool. Yeah. Oh, that's the wrong one. This one. Okay, cool. Because this is in, this one is in local space for our grab point. This is in global space, our tracking point. We're going to compare those two. How much has that been rotated? But around our destination vector, which is why we need to do it like this. Okay, so now, and this is really where I wanted to, because the problem is I've got this all done like this. Do I want to create a new object to grab? I think I want to put a new object to grab to, I don't really want to mess about with that one. So let's just quickly create just another thing to pick up. Let's move that out of the way a bit. Okay, we're just going to add a rigid body in. There we go. Go up, place that properly in a minute. We're going to do that. Name that test. Now we're going to go and add a collision shape to that. And we're going to add a mesh instance to that. I'm not going to care about finger position and stuff. We're just going to quickly put something together. So this is going to become a box. This is also going to become a box. We don't want it that big, so our box is going to be nice and small. Okay, that is good enough. Y. Okay, let's go and put you a little bit more like that, just the forefront. I think I want that to be a little bit bigger though. So let's make that 2. 2, 2. There we go. We've got a nice box to grab. And obviously our collision shape also needs to be the same size. There we go. And now we're going to add a grab point for our left hand first. There we go. Let's show that. So, okay, so our left hand, I actually want to rotate 90 degrees. Okay, let's make it nicely 90. And I'm going to do that. I'm going to do that. And actually, if I go here, did I save that? Yeah, I did. Ah. So just to make that a little bit nicer. This is one of the things that's really cool about that finger posting. You can save those resources. I'm guessing I'm put it in somewhere. Nope, not there. Where did I put it in? Components? Yeah, I think it's this one. Yeah. Boom. There we go. We have our finger poses. So I don't really care about the exact positioning, just that it's kind of there. All right. The other thing that I want to do is put material on this thing. Make it transparent. No. Here. And just make that a bit of a bluish color. And I'm going to make it transparent. I want to see anything that we position through there so that it becomes nice and easy to recognize. Let's create another grab point. You should not be there. You should be there. That's going to be our right hand grab point. Okay. Now you are going to show the hand. It's going to be the left hand. We can again just go and put our finger poses there. There we go. And we will put that roughly in the same place. So the reason I wanted to do this, I wanted to make sure that we have that situation where our destination vector, which runs from one hand to the other, isn't perpendicular to the hand, but it's angled, because our logic still needs to work at that point. Yeah, Post, what's up? All right. So with that box in place, let's go have a look if our vectors are now being displayed in a way that we like. Yeah, Kat, I know you want attention. You hear me talk? You think I'm talking to you. I'm talking to people. Yeah. Shame that my cat doesn't really like it when I pick her up, else I would go and show her off a bit. But she is just walking around. All right. Oh, what just happened? Oh, there we go. Yay! My hands got stuck to each other. That was fun. All right, so grab the box. I'm holding a nice translucent box, as you guys can see. And now I'm grabbing it with my other hand. All right. So can you guys see the vectors? So if I'm holding it in the right spot, you can see that they nicely line up. They're also nicely in line with that. But yeah, based on how much I turn my hands, that blue one nicely turns. The white one still points back. I don't know why it still points back, because we do a cross. So that's really interesting. Wonder what. But still, they are in the right order. They're not locked to the hand. They are actually pointing in the direction that I expect. And yeah, that's a little bit having problems with that. I guess because when I do things like this, it's becoming, I'm now turning my hand around its own axis, and it doesn't really know what to make of that, which is kind of logical, because now, yeah, I do. Well, it's not much that we can do about that. We'll need to put some constraints on our rotation, I guess. But I think we got the basics here. Yeah, Yeah, it makes sense. If our hands are really in a different orientation than where our grab points end up, it makes sense that it starts struggling at that point. All right. But our vectors are, yeah, they're working in the right plane. Okay, so now we need to calculate what the angle between those two are. And then we need to make sure we need to make sure that we have those in the right plane. All right, cool. Cool. I think we're very close to where we want to be. All righty. Hello, cats. Go say hello. Here, over there. People can see you. Meow. Meow, meow. Let's see a bit better. That's my cat. Hello, cat. And you a happy cat, huh? You like lying on the computer. Nice and warm. Help me overheat my computer. All righty. There we go. Cat cam. Okay. Well, with that, I am going to put our label back. Let's be a little bit smarter now and actually put some text here so that we can see what things we want to change. One of them is, I actually want that left aligned, so we can actually see that now points out. And I don't want it to be so humongous. So we're just going to go and put that down a bit. That should be all right. All right, so is there also something here that can billboard this thing? There should be a billboard function here. No flags? Maybe. Yeah, it is. Here we go. Let's make that a Y billboard so that we can always read it even if we hold our hand in a weird position. Okay. Because I want to just be able to have somewhere to print the angles that we're calculating. All right. Scripts. Pick up. So now the challenge is going to be to get the angle between that and that, and the angle between that and that. Take the average of those two, and then rotate around our destination vector and add that into the rotation that we already have. So I'm just going to go and copy this for a sec. Bonk. All right. And we're going to say start cross with destination. And then we do start dot with destination. Now, this should come up with a vector that is equal to our destination vector, or pointing the opposite direction. Oh, I don't need that in there. And actually here, we're going to go and do a var primary angle. Because now we really want to see, okay, if the cross vector, we're going to assume that that nicely does line up with the destination vector, although we probably can do something fun with that. Now I have to remember, if I remember correctly, if two vectors are aligned and you do the dot product, we get value 1. If they're opposite, we get -1. So what we should be able to do here is we should be say if cross, not cross, that's funny, best vector is smaller than 0, we need to say primary angle is minus primary angle. All right. Sorry, not cross, dot. All right. Now let's repeat that for our secondary. So here we're going to call that secondary angle, and that's going to be secondary start, secondary depth, and we reverse that one. All right. So that should be in radians. So now what we should be able to do is get node, load the spell bars, primary, secondary, and we're going to do a rad 2 degrees on our primary angle. And a rad 2 degrees on our secondary angle. Cool. Let's go and have a look if that makes sense or not. Ready. All right. Cool. Let's grab our box again. Hello. Ooh. Yeah. As I move my head, that gets into the wrong space. That's I definitely need to make it smaller. Yeah, you guys can see it better. Oh, that's interesting. Oh yeah, that's because in the shader that is the billboard works in the shader. So for me, when I look at that text, it tries to align itself in my headset, so I can actually see it turn as I turn my head. But then it gets too close to me. For you guys, you can nicely read it. So if I nicely line these up, we go to about 0 degrees. So if I point that down, we go to -50. If I point that one down, also around that. Cool. And can I, oh, this is uncomfortable. So we go positive if we go that direction. Righty. We have a rotation that we can use. Very promising. Okay, that the billboard thing here is hilarious. That it is different on screen than what I'm seeing in headset. That is absolutely hilarious. Completely understandable, but hilarious. I'm going to make the text smaller so that I can see that better. But we now have our angle. So the last thing that we need to do is we need to get our global target basis. Yep. Cool. Global target basis. And we're going to multiply that with the basis that we're about to calculate. So we made sure that our angles are aligned with the destination vector. Boom. Primary angle plus secondary angle. Oops. Let's put that between. Let's actually go and make that a bit bigger so that you guys can see. Times half. And that should give us the average between the two angles. Let's go have a look if that makes sense. Alrighty. All right, grab my box. Oh, grab my box. There we go. Grab my box. And now, oh, I still have the, I'm wondering, why is it so weird? I think I mentioned about the grip poses being weird. Well, this is what I mean by the poses being weird. Um, let's go and put the hand tracking back on again. Um, I definitely need to do a little bit more work with that. But hey, uh, that looks exactly like what I wanted to do. Now I can move this in really weird things, and I can flip it around, but my cube is being positioned properly. Let's see if it also still works with that cube. Yes, it does. Cool. All right, let's turn hand tracking back on so that I have a proper orientation of my hands. So I guess I am falling back to grip. No, I am using palm pose, so I wonder why it doesn't feel natural. I do not like the poses at all. This is why I love using the hand tracking. It's so much more predictable. All right, hand tracking. There we go. All right. Oh, let's make sure that this is on screen for you guys. I should really change the settings so that it automatically goes in the right position. Here we go. All right, let's see if that feels a bit more natural. All right, so this is why I was confused with the vectors being, you know, pointing backwards. Now they're pointing upwards because, of course, I had turned hand tracking off, and as we already discovered in hand tracking, when we look at the positioning of the poses, they are different. But our solution, even though everything is now pointing in a different direction, as you can see, they're now pointing upwards, as I was expecting, the mechanism works the same. Now I'm still having it, I can't really, maybe it's because I'm holding myself up. I don't know. Yeah. The other thing is, I don't know if you guys can see this, but I'm pushing this through the other boxes. And even though we have all that logic that is trying to make it align differently, the physics engine is now not allowing it to actually be positioned in the position that I want it to be, which is perfect. Really cool. Very happy about that. So yeah, that explains why we suddenly weren't having the vectors up. But this is working exactly as one. Also, obviously, if I'm holding one really twisted, the other way, it now nicely averages out. Still, I guess the palm post is in the correct position. It feels very uncomfortable trying to rotate it down. So I'm not sure if even with the hand tracking, no, is it because of how I've placed my, maybe it's because of how I place my hand, because the middle carpal bone might not be completely straight. I don't know. But yeah, it feels uncomfortable to try and move my hands down. But again, I'm also sitting behind a desk. I'm having my hands pretty high, so it's fairly likely that is why that feels uncomfortable. I think if I would normally be walking around and I would be holding my hands lower, it would be more natural to do that other motion. But I think functionally speaking, this is doing what it should be doing. So with that, let's get rid of all our helper things. And let's get rid of these two. And let's go and get rid of that little bit of code. There we go. Now I wonder if I should clean this up a little bit. We're doing some things a little bit double. Nah, I'm happy to have that written out like this. Yeah, no, I want to create a helper function for that, because it gets really hard to read this way. So let's go. Don't have that open. Let's go into my helper class. The angle, rotation, very cool. Let's go and put another little helper function in here, and we call that calculates the angle between two vectors within the plane of another vector. All right, static func angle in plane vector 3 A B 3, and that should output a float. And let's just make it return 0 for now. All right, so let's go and copy all this here. Do we have a... Oh, shift tab, okay. There we go. All right, so that's going to be our input for A. So this is going to be PA bar A vector 3. Okay. All right, we're going to do the same for B. I'm actually going to now do this. Okay, so that's going to be A, B. So this is going to be A, B. Our cross is going to be a vector 3. And we do that. And now we can say angle minus angle, and we return our angle. There we go. Sweet. And we can probably potentially find some edge cases. But that's the nice thing about doing it like this is if we have edge cases where this calculation fails, we now have one place to figure that out in. So with that, we're now going to go and move that out of the way. And instead of this, we're going to say XRT2 helper dot angle in plane destination vector A vector B vector. Alrighty. Cool. Here I'm just actually going to go and duplicate this. I'm going to call that secondary. And here it is. Running out of screen real estate here. Whoop. And whoop. And now I've deleted all this code. I'm going to find out that we forgot something and we messed up. Hopefully not. Alrighty. Okie dokie. So. Cool. Yeah. That's good. Looks like it does what it wants to do, or it should do. Hmm. That feels very natural. Whoops. Don't know if you guys saw that, but I shot that off the screen. That's one thing that I do still need to do is if you look at this, I can, in a two-handed mode, I can pull this back, right? When I let it go, it shoots back to single-handed mode. All right, and that gives that a nice velocity. So if I let go of my left hand and then really quickly after that go of my right hand, oh, that wasn't quick enough, I can make it flip and I can shoot it. So just by letting it go in the right order, first causes it to get a spin, and then the second makes it go off. Can we justify that? I'm not sure, but that is still an improvement on the let go logic. The let go logic right now really and it has an emphasis on the physics rate matching the headset rate. Or actually, I should say that the physics rate does not exceed the rate at which we are getting tracking data, or we're tracking data updates. Let's say that, for argument's sake, our tracking data only updates every 30 times per second, while we are handling our physics at 90 or 120 frames per second. That means that our hand will stay in place for 3 frames and then moves there and stays in place for 3 frames, and then moves there, stays in place for 3 frames. So in that frame where it moves from here to here, we are applying physics, we are making our object move, and assuming that nothing gets in our way when it's now here for 2 or 3 frames, we have no velocity. So if we drop it on that frame that we're moving it, we would have a velocity for it to fly off. But if we're letting go in one of those frames where our hand hasn't moved because we haven't been getting new tracking data, or there's no new tracking data available, it wouldn't. Now, as far as I'm aware, the way that OpenXR works is even if the optical tracking or whatever isn't updating at 90 or 120 frames per second, it is actually doing a estimation based on velocity of the hand. So in theory, every frame that we are getting new data in, we should be getting that movement correctly. And again, like I said, this is where it's important that the physics rate matches our headset rate, because we are updating that information at the rate that the headset is rendering. We're not doing that in our physics process. Another little problem there, that potentially we could have a problem if you're running physics on a separate thread, because that will also be out of sync. So there are some things there that we might need to improve upon in the way that we are calculating the velocity that our object is moving at when we're letting go. Now, one of the options there is we can actually query OpenXR and get the velocity information of the hand, and then assuming that that matches the velocity at which we are moving the object at the moment that we let go, we can use that as a projectile thing. I am still undecided what the best option is there. Personally, for the most part, I actually find it very natural how the pickup and let go logic works, including letting go while moving the object so that it continues its trajectory when you do it single-handed. You're doing it double-handed, and it's in that frame or two that it takes for it to go from here I was, here I want to be. We are getting a whole bunch of velocity that we really don't want. So there is some argument to at some point in our pickup logic when we let go is to say, hey, are we still processing that data from, hey, I only just one frame ago let go of my other hand. So I'm not sure there. Those are sort of like the tweaks that we will do as time goes by, or the improvements that we will do as time goes by. Ooh, almost knocked over my water there. The core of this is good. I truly believe that what we have got here now is good. It's in some of the details that we probably want to do, either some smoothing or we might want to add some. Where is our drop logic? Drop held object. So here in our drop held object, basically all we're doing is we are now undoing the freeze state, I think. No, we're not even doing that. We just stop putting forces into the object. So it's just going to move off at whatever velocity it has at that point. Which, other than that letting go and then it just flips and gets one frame of really high rotational energy. Yeah. And yeah, that might then be something that we would need to improve in our physics process here. Maybe one thing that we need to do here is indeed detect that we've just let go of the other hand, and instead of it immediately snapping, is that is the one situation where we're actually lerping a little bit. And that could actually be something as simple as in our torque calculation here, where we're applying the full torque. We actually have a value here left over from some of the two-handed logic, although I am applying that over here. That we can do this proportional. So one thing that we could do here is have some sort of timer sort of thing, saying like, hey, if the other hand had this, so we do here, if we have an other, and we could do something here like, we can actually, no, we can't do it there. We would have to do it. Because if we're the secondary hand and we let go of the primary hand, we just got the issue in reverse. But the solve is the same. We just need to find out, okay, at what point do we measure that the second hand, whether that was the primary or the secondary hand, has let go, that we don't want to do this quick snap. Because all we want to do is have that one be a little lower at that point. And actually the same thing with this one. We would want to have this one be something less. Okay. All right. I actually want to have something for this. So where are our picked up things? Do I still use my tweet? Yeah, I do. I think I do. Picked up, grab points, and grab float is 1. Cool. So what we are going to do now is we want to factor there or just no, I want to do that as a bool. is actually secondary to and delay. Let's call it like this, is 0. Cool. All right. So what we're now going to do is in our pickup logic, pickup logic, yeah, here, we're going to say if we're secondary, we're going to make sure that, you know, we've picked this up. We are the primary. We want to make sure, okay, there's no second hand yet because we only just picked it up. If we are the primary pick up object, nothing else is picked up, we're the first one. We can do our normal thing. So we want to make sure that that becomes true. All right. Hold on. That was not true. That was 0, I think. Because it's a delay. Yeah, 0. Sorry about that. Oh, that wasn't what I had in mind. 0. All right, cool. Now, when we drop objects, so we are now the hand that's letting go. What we're doing here at the end is we're checking if another hand is holding this. And if we have another hand that's holding it, that hand becomes primary. Might already be primary, but it also becomes primary. So what we're going to do here, we're going to set that to 1 second. Might put it to something else. For now, it's 1 second. So if I'm the first hand to pick it up, I'm making sure that it's 0 so that we don't listen to this value. If the other hand is letting go and I'm the one hand remaining, I get my 2-hand delay again. Sweet. So now in our process, what we're going to do is I'm actually going to make a variable for this. Oh yeah, I want to make that a setting somewhere. That's fine. For now, it's hard-coded. That's fine. And that's actually something we'll do this next because that is actually a nice thing to implement as well. So, primary vector float is 0 if 0 else. We're just going to make that 0.2 for now. We've got to, again, our 1 second delay is probably way too much. We're probably going to make some constants for this or some things that we can configure. But I just want to, you know, because now it's going to be very obvious what we're doing. And we can see what it's doing. All right. Because the second is definitely too long for this, but it's just what we want. So we need to go and use that over here. Yeah, because we're in 2 hands. With 2 hands. We might need to fix that up as well. All right, so that here as well. Another thing that we're missing, and we can actually do that over here, now that we do this here, is 2-hand delay. It's going to be max 0. We don't want it to become less than 0, but we're going to subtract delta. So that should slowly count down from 1 to 0 over the time of 1 second. So again, we're going to go and make sure that we are going to make that a settable thing, and we're going to make our delay a settable thing. However, the thing that I've missed is, let's say that I let go. So now I'm going to count down. If I immediately grab again, I immediately want it to snap again. So, or do I? Yeah, I do. Do I? No, I don't. I actually want it to delay when a second hand picks it up. That's the same thing, right? Is if my second hand picks it up and I snap immediately, no, I don't care because I'm not letting go, so I'm not shooting it off. So no, at that point, I don't care that it snaps. But I do want to make sure that if I let go and my timer goes in and I grab it immediately, which is very unlikely, but it is possible. I also want to do that. So here, oh, because I. Oh, this is only checking if it is already picked up. It's not who did it pick up. Kind of want to know who the other one is. So at this point in time, I have not added myself, I think. Yep. Okay. Other. So I'm picking up. If other. Then we are not primary. But now I can say other to, and the delay is 0. So I can reset that. Because again, that needs to be set on the primary. Yeah, cool. All right, this is going to get interesting. I'm happy with the 1 second delay right now because it hopefully will let us see what's going on and see if this actually makes sense. But obviously, I am going to want to. Come on. There we go. Hello. Check my other end. There we go. All right. Let's go grab you. Yay. That's still working immediately as it should, but now it's still working. Let's go and make sure that it. Okay, so we can see. Boing, boing, boing. Now, obviously, it's getting there within the second, but you can see that it actually doesn't immediately go crazy. I can still flip it. Now, I think the 0.2 is probably a little bit too less. Let's go. Oh, okay. So, okay. So because now, remember the logic that I'm sticking it to the primary that's currently on. It's almost working like a rubber band. Ding. But yeah, we can see that this logic is properly working. Like the last hand that holds it becomes the primary and becomes the one on which we do the delay. All right. Okay, so. And the other thing here is, why am I bobbing? I'm bobbing. The other thing here is that I definitely need to fix the bobbing. The further apart my hands are, the longer that delay probably should be. Nah, I'm actually happy with that. We're going to go and tweak that a little bit. All right, so we need 2 variables. Are we going to make that something that we are going to make user definable? I think we are. All right, so we have detection all set. Let's all grab toggle. Yeah, that's also something that still needs to figure. I think that actually also needs to be moved to the object that we pick up, but that's all right. I'm not going to be really worried about that too much right now. All right, let's go and just create some new variables. What do I have to do here? Now I just pick up regex. Yeah, we no longer have logic. Oh yeah, we actually kind of have that, don't we? Hold up, let me pick that by what? Yeah, yeah, we have that. All right, let's take out that remark here. We actually have that. That is a static function here. Cool. All right. So we have our two-handed delay. We want to. I don't really care that that is going to be the same name. So let's say export var. Make that a range. 0. Someone wants to turn it off. They can turn it off. I'll do it like this. Var is, make that half a second. You don't need to do anything else. When the second hand lets an object, how long do we delay our snap? All right. And then we're going to have a export range 0 to 1. It should never be 0. That would be really bad. Var to let go factor. I'm going to make that a little bit stronger. See where we actually end up with that. And an object is let go by one hand, still held by another. This factor is applied to soften or let go. And the other thing is, should that be? No, I think in this case, the delta side of it is already handled by the physics, so I am pretty happy about that. All right, so let's start first by going here. So 0, 0, and here we set it to 1. So here we're going to go and set our two-hand delay factor. And then here we need to have our let go factor. All right, let's see if that works. Actually, before I run this is every time this gets me, my scene is open, and that means that we might need to do that. And on this one as well. So when your scene is open while you're adding new export variables, it's very often that because that script, I think this only happens with tool scripts. I don't think this happens with normal scripts. But when you have a tool script, because that script is already running in memory, you're now adding export variables that when that script was instantiated didn't exist, it gets confused and it will not have the correct values here. We saw values, but they don't actually exist. They're actually nil in the background. And when you then run your application, this is now set to nil, and obviously we're going to get errors. So that's just a little warning. I wouldn't go as far as calling it a bug. It's an unfortunate consequence of using tool scripts where you're changing something that is already running. And that is just hard. So normal movement, boink. Cool. Boink. Yeah, I like this. Boink. All right. Boink. Yeah, this is really cool. I'm very happy with how this works. You know, the little boink, that's just funny. Although that does mean that, oh, let's hope that I can get close enough. There we go. All right, cool. Let's try this with a heavy object. Come on, go away. Make some room. Oh, that didn't actually. It has a little bit more of a bounce, but yeah, pretty happy with how that works. Sweet. All right. Cool stuff. Oh, just for fun, so you can still see that doesn't work very well. But yeah, what do we do? Not happy yet about that, but that's just constraint logic. It's not as bad as it was, but yeah, it's still struggling with that. But you can't even do that in XR Tools 1, so I'm willing to accept that as a limitation for now. Okay, so we now have the letting go is no longer going absolutely nuts. It would still, if I let go and that thing is moving, I let go with the other hand, it would obviously continue on its trajectory. But actually, that is a nice secondary to show, because there is another problem with this, and it's actually in this situation that's really easy to demonstrate now that we've done this. So this is the next problem that I'm going to solve. This has been on my list of things to solve for a long time. So, well, first let's solve or make hey, I want that behavior, instead of doing this, that it actually stays halfway between the hands. And that needs to become a property somehow, and we need to think about that. But the other thing is, so I'm moving that like that. Cool. Now let's do the same thing. Oh, that actually flew off. Okay, I was kind of expecting that. Yeah, let's go. No, that didn't have any. Okay, that's interesting. So obviously it still flies because we still have momentum. It's still moving from where it was to the hand that I have. But I was actually expecting it to collide with my hand, because that's like, in this case, it's actually cool, because it's sort of, when you let go, it still sort of is colliding with your hand. So it just sort of does that. But, and I guess I kind of solved that with the posing, because the posing, well, no, actually doesn't, I'm actually not too worried about that, I guess. This is difficult because, oops, I accidentally moved there. This is a Steam frame, Michael. Because in a situation that I actually have trouble with this, is, let's say that you're holding a weapon and you've got your finger inside of the handle. The moment that you let go, the collision of the hand is still potentially causing the object to collide with the hand and get stuck, which is annoying. But in this case, it actually worked for us. So do I really want, because in XR Tools 1, we had the same problem. And what we ended up doing is to create a delay, because whenever you pick up an object with a hand, I'm actually turning off collisions between the hand and the object that you're grabbing. And when you let go of the object, I'm turning those collisions back on. And if your hand is colliding with the object, it's possible that collision can actually cause that object to fly off. Because especially if your hand is inside of the object, the physics engine is suddenly going and saying, oh, I've got a cube here and there's a head inside of the cube, help! And it's, especially if you're very deep inside the object and you let go, it's going to rocket through through space. So, like I said, in XR Tools 1, we temporarily disable the collisions. And in this case, I wonder if we want that, because in this case, if I'm holding the cube on top of my hand and now I'm letting go, if I keep the collision disabled and The idea was to keep it disabled until we are no longer colliding. The cube would just fall through my hand. And that's very unnatural. So the big question is, what do we want to do there? And in this case, because the posing allows us to properly place the hand, it's unlikely that when you let go that it has a collision that we don't want. In that case, when you let go, the collisions are likely the collision that we actually want to happen, which was why the cube so nicely fell off my hand when I let go. So is that a property of the object that we let go, whether we want the collisions to be immediate or if we want to delay removing the collision exception until the object is no longer colliding? Or, like I did in XR Tools 1, we just gave a delay of 1 second, assuming that by then the object had fallen far enough away. Which in 9 out of 10 situations is fine, it's working. I kind of think that both are valid approaches. And I'm going to leave that alone for today. And that is really something where, as people are starting to play around with this and making some more complex things with Godot and with XR Tools 2, that we hopefully get some feedback and decide on what we want to do. Now, the pivot and primary. Here's the problem. One of the important differences between XR Tools 1 and XR Tools 2 is that I've made a decision that any rigid body should be interactable. In XR Tools 1, you had to inherit from a base class that has all the logic to allow something to be picked up. But that meant that you couldn't just apply pickup logic to anything. So in XR Tools 2, we've let that go. In XR Tools 2, we have said you can pick up any rigid body. If I just put a rigid body in the scene and I add a collision shape and I add a mesh, like we did just really quickly over here, right? If I hadn't added these grab points, I would be able to grab that cube anywhere and it would work. Now that logic for determining where I'm grabbing the cube, that still needs some improvement. And whatever pose I apply, that still needs some improvement, but it would pick up the cube. Now the problem that brings in is, this is a standard rigid body. There are no properties on that rigid body that determine the behavior of that rigid body. Now, the grab points are our first version of, and actually I want to hide that in a minute. Can we prevent rigid bodies from being picked up? Yes and no. The way that you would do that right now is by placing the rigid body in a different collision layer. So the rigid bodies by default are in collision layer 1. And by default, when you look at the pickup, we are only picking up objects in collision layer 1. So if I would place this rigid body into layer 2, I would no longer be able to pick up this rigid body. That's currently the only way to do it. Maybe that is something that I will keep and not do any other way. But I'm also tempted to do the same thing that we are thinking about right now here. So the grab points are kind of the first thing that we have done in this approach. We already had those in XR Tools 1, but that approach of, hey, I'm going to add a decorator node to my physics body that allows XR Tools to know certain behavior. Hey, suddenly we have a way to extend how this box, which is meant for, let's say that you have a game that you can play in XR, but also normally on the desktop. Normally on the desktop, these decorators are going to be ignored. The desktop app is not going to care about that. There might be completely different logic of how this box is going to react to being picked up, because the pickup will be based on pressing the E on the keyboard based on where you're looking and that sort of thing. So we are going down the path of creating decorators that do things. So what we really want to do for something like this is have a decorator that says, this is how I want you to behave differently. And the question that I have at this point is, do we want to have a single rigid body decorator on which we add additional properties that drive the pickup behavior? Or do we want to just have a node, in this case, that purely by the existence of the node on the rigid body, we know that we want this type of behavior? That is the question. And I'm kind of leading to the first option, creating a single node that you can optionally add to a box, and that defines the behavior, the XR behavior of that rigid body. Sorry, you can add to a rigid body and that defines that. Because there's similar things also when we look at static bodies. Now, static bodies are even more important. Well, we don't want, once we implement the static body logic and we look at our world, we might not want the user to be able to climb any of these things. We might only want to be able to have the user climb something that we've designated as climbable. So in this case, do we want to put everything that's not climbable in a separate collision layer? Or do we want the static body logic to be, hey, by default, you can't climb this unless there's a grab point or there's this decorator that provides XR information. So that is still a way up that I have. And again, that's not the exact opposite of the behavior of rigid body. In rigid body, we said, by default, you can pick up any rigid body unless you've done something like moving it into a different layer or something else that we might introduce. And then for the static bodies, we would do the opposite. And I'm conflicted about that because on one side, I don't like opposite behaviors because that is unpredictable. But on the other side, it's logical that by default, you can't climb everything. Because that's, of course, the problem, right? Is if we by default make everything climbable and a developer is not aware of that, well, first of all, there 9 out of 10 times, nothing is climbable. So you would have to add stuff to every object. Instead of, if we make the default, you can't grab every static body. So you only put the decorators on the objects that are actually climbable. But then it's reversed from how we work with rigid bodies. I'm leaning to that second one, by the way. I'm leaning to saying by default we can pick up any rigid body, but you need a decorator in order to grab a static body. And that just needs to be good documentation. That is what I'm leaning to. Simply because that is the logical conclusion of a world like this. So yeah. All right. So how are we going to call this? Where are we going to put it? No, that's just effects. Is it part of our hand logic? Maybe. It's definitely not MISC. That's things that we attach to players. I think we're just going to go and create a new folder for objects. And let's go and create a folder in here. Let's just call that behaviors. Or no, let's call it decorators. So it's tempting now to actually put our, where is our grab? Where did I put my grab on? Where is that? Because that makes sense to actually have that in a decorator folder. Oh, the grab point is in components. I think that is actually nicer, but I'm going to create a folder here called decorators. And then our grab point is going to be part of that. Now, anybody who's already using the, oh no, actually that's why the UIDs will come in handy. It'll fix itself up. All right. XRT2, rigid body behavior. Should be a Node 3D. Great. All right. Let me just steal this. Too many things. Here we go. Class name rigid body behavior. XRT2 rigid body behavior. Rigid body behavior. There we go. All right. Export var. What did we call it? Pivot and primary. I think that is a brilliant name for this. Oh, yes, sure. No, I'm going to make it default false because that is the default behavior if we do not have this. Okay. If true, and this object is picked up, the primary, the object is centered in the foot and it's the object. All right. If false, the object is placed both hands equally affect position. All right. I do want to make this a tool script because we want to do a get configuration warnings. Warnings, string array, which is also what we are going to return. Okay, return warnings. Parents is get parents. If parents, no, if not parent or not parents is rigid body 3D. So this is only for rigid bodies. Warnings. Push. This node must be a child of a rigid body 3D node. And let's put a description here. XRT2 rigid body behavior is a decorator node for rigid body 3D and allows us to define additional behavior characteristics when this object is being held by the player. Cool. All right. So now in here, we don't want to check that every frame because that doesn't make sense. So we're going to go and pivot on primary. Oh, no, that's fine. So we're going to move that out. And we're going to first move this to all the way up here somewhere. All right. Let's move that in here. I actually want to put that in above there, but we're going to put an underscore in there to make clear that that is that. So we're going to turn that to false. Okay. Boom. Boom. All right. So what we're now going to do is on our logic, we're going to pick up this. Da 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 da. Da da da. All right. We can put that here. All right. So here. Okay, so here we're going to say var here good buddy behavior is okay. Which dots node? All right. Is there a node where you can say get the first of a certain type? Else we need to make something like that. Actually, we're going to make that simpler. We're actually going to make that really good. Simple. What we're going to do here, it's going to complain about this because we haven't got it here yet. Behavior. All right. Dang, nodes are not. All right, that's fine. We'll just allow it to be null. So here we're going to say static for rigid. Oh, that's something that we need to change. Actually, I am going to go and call that node 3. Return. Okay. If T4 is good bloody 3D for child for net children, if child is return child. Simple as that. So if we happen to call this for something else than a rigid body, it's just going to go and return null, which is perfectly what we want. If it doesn't exist, going to return null. If it does exist, cool. Sweet. All right. Okay. So if we have this, pivots primary is pivot on primary. Else, because well, we might have a value from the last time we picked something else. We want to set it to false. Now we could have other logic here at some point. we're doing nothing specific here on the type anymore. Cool. So let's say that we also have a behavior node for static bodies later on. We can do more things like this there. It's fine. Although I've got the feeling that what I really want to do is just reset this on drop. That makes far more sense. Yeah, because if we have other sort of logic, then maybe. I don't know. What is smart here? The defensive programmer in me says it should set it to false in the code here. It should not assume it. But I kind of also want to do if which is rigid body 3D, and we have this. And we're not using it in other scenarios. Yeah, you know what? I think this is safer. This is safer. We can still have that reset here just in case. It can't do harm. But we're assuming that if it's not a rigid body, it will never go through code that uses it anyway. So we don't really care. All right. So let's go and add our decorator over here to our box. And we're going to say pivot. Actually, the type is wrong. I do not think this needs a position. So, you know what? Let's just go do it like this. Behavior. There we go. Makes it a little bit more cleaner. We don't need all that other stuff. Just to store settings. And we might have other settings eventually, right? There might be other behavior things that we want to add in here. So what we now have is, this is kind of dumb that we have it on pivot. You know, obviously I'm going to be removing this eventually, but I just want that to, as an example. What I also want to do is go and hide this thing again. I wish I could detect that I'm actually editing this scene and only make that work when I'm editing the scene and not show all the hands over here. But yeah, so all our boxes now have that behavior on. Yeah, we put it on, right? Yeah, do it. But our little transparent box, oh, we've got that in the world, of course. Our little transparent box doesn't. So our little transparent box should still have our, no, our little transparent box should now do the center logic. And our normal boxes should have the behavior that we've been having all stream. So let's have a look and see. And I'm going to turn it off on the boxes, but eventually we're going to have some sort of object here where it makes sense to do it differently. So holding it one hand, that's all fine. Holding it with two hands. So now you can see that the box is centered, dead center between our two hands. And obviously when I let it go, it will still do that logic, but it has less far to travel. So go over there, you. Oops. No, whatever. So now I'm holding my other box, and this one has that behavior. So we're back at that pivot on secondary hand. So now our right hand defines the position of our box, and our left hand defines our orientation. We still have our logic that we can twist the object with either hand, but position-wise and orientation-wise, each hand has its own purpose. Cool. All right, that's pretty. Oh, you guys didn't see any of that. Let me try that again. Let me actually just restart it because obviously things are on the floor now. Let me redo this. Oops. All right, here we go again. Yink, yink, yink. So let's go back. There we go. So again, with my My normal box that doesn't have the behavior property. The box is now centered between the two hands. Whether I do that or that, doesn't matter. It nicely stays there. I can do that. And when I let it go, it still has that bouncy logic. And if I put that back and I grab this guy, then this one does the logic that we had before. Okay, so sorry about that. I forgot to move the screen. So just to get that properly shown. Oh man, that is actually really, really good. So again, we'll probably have other logic that will add to that behavior node. And we'll probably do something similar with the static bodies. But with the static bodies, we might flip the script around. With static bodies, we might say, hey, you can only pick up a static body if it has a grab point or if it has a static body behavior node or something like that. I need to think about that some more, but I think that is something, as long as we have some good documentation about that, that's the other thing that I need to start working on, get some documentation going for this. So yeah. All right. I'm really happy about this. This is really coming together now. I think the way yeah, so that's a remark that I'm not going to deal with yet. So this is another thing just for anybody who's interested in knowing that. So right now, when you are using the collision hand implementation, the pickup logic does everything that we want. But the pickup logic is designed to also work with a normal XR controller 3D node. But because we now have no knowledge about how you are adding a hand to that and how you are setting up the behavior of the hand, we are missing a piece. And that is something that I do want to add at some point, but I'm having difficulty knowing what scenario someone doesn't want to use the collision hands node, seeing how much they actually do nowadays. Probably wrong about that. You never know, but yeah. This is the other thing that I just want to clean up. This is it makes my the back of my hairs stand up, right? You should not be modifying something inside of a random node, because that means that if the logic of that node changes and suddenly we rename something, we break things, that should become an API on the collision hand. And this logic should move into the collision hand. But I am not too bothered with that right now. So yeah, here we still have a placeholder for that. But the thing that I wanted to start looking at is, did we overlook anything here? So that's now a declaration, so that can go. Okay. Yeah, I'm actually thinking that this logic is now complete. Well, we also need to do the static body part of it, but for rigid bodies, this is complete. Oh, we also do physical bone. All right. Let's make sure that... Should we turn that into something broader? No, I'm going to be happy with or okay, so that needs to be there, and I need to do the same thing with the pickup here. No. There we go. Yeah. And this must be a child of a rigid body or physical bone node. So the physical bone thing, we actually don't have that as an example here. I had that as an example in another test scene that I had a little while ago. I might bring that back in here. but I had a ragdoll hanging from a hook, and you could grab the ragdoll in all sorts of places, which was kind of cool. All right, so that works. Hey Betty, how you going? So I'm actually going to turn it off because I don't actually want that logic. It doesn't make sense for this object, but I am going to leave the node here just as an example. But we will be adding something to this. I'm actually thinking about seeing if I can find a water gun. Yeah, that is the steam frame, baby. Yeah, I'm actually thinking as a oh, cool. Well, I'm not big on AI, but you know, if that works for you, great. So yeah, so I'm thinking about because you know, everybody does guns because guns are fun in XR, but I kind of want to have a non-violent gun in my demo. So I've been thinking about having some fun with that. Then again, a bow and arrow is also something that I always like for these sort of things. But I don't have any assets for that right now, so I don't want to go sit here and hunt for assets while playing. Yeah, Bailey, I agree with that. You know, there's good stuff that you can do with AI, and there's really bad stuff that you can do with AI. It really depends on what your use case is and what you do with it. You know, headsets, you know, whether this one or any of the ones behind me, obviously AI is big in headsets for the vision part of it, and you know, without AI, most headsets wouldn't even work. But when you're looking at the idea of let's use AI as, oh, now I don't need to hire people anymore. Besides the moral part of that, I also don't believe in it. I think that if you think that you can replace people by AI, you might be impressed on the short term, but you're going to get into trouble in the long term. But if you use AI as a supporting tool, you know, AI to help you weed for information or through information, or use AI to check the coding that you're doing. Some really good ways of using AI without it being destructive or this is placeholder text. Oh yeah, that's for my log. Like, why is there some text in the middle of? But yeah, there's a little transparent window there. I actually there's a feature in Godot that anything that's sent to the output here, you can redirect and do whatever you want with it. So it unfortunately starts slightly too late, so I don't capture the beginning stuff, which is why you don't usually see things. If something goes wrong and we get errors in our log, it actually comes in here and I can see it while I'm playing, which is kind of cool. My game startup is using open source AI models run NPCs. Yeah, I saw someone else post about that as well, where and I know that Teddy was doing that really early on, and he was using it to record what you're saying, then feed what you're saying into an AI model to then have his NPCs react to what you're saying. And if you do that right, I think it's cool. And if you do it wrong, I think it's dangerous, because you look at all the AI girlfriend nonsense that's going on right now. If you go in that direction, I think it's very destructive and potentially very harmful for people's mental health. But you know, in a game scenario where you want NPCs to react a little bit more flexible than just having fixed scripted responses, I can see that could be really cool. So yeah, if you manage to do something cool with that, I am interested in seeing it by the time that it does something. Yeah, the AI girlfriend trend is horrible. I think, um, yeah, I get why some people are attracted to it, but I I think that there's so much danger there. Anyway, back to this. I'm trying to think about what we can still do because we've been streaming for how long now? Almost 3 hours. So I need to start thinking about dinner soon. Um. Oh yeah, that's cool. That's probably a decent model. um. All right. I'm tempted to start working on grabbing static and doing a climbing mechanism, or at least get the start of that working. Or should I first work on? I want to be able to grab something anywhere. I don't know. I don't know. I don't know what's smart there. Because it kind of, especially when we're looking at grabbing something big as this, the current logic that I have, which by the way is I'm shooting a raycast from where my hand is to the center of the object to try and see where I collide. And yeah, no, that's not really a good thing to do. What I'm thinking about now is to actually either look at the circle and find the intersection point between the circle and whatever we're touching, but I'm not sure if I can. Or to just shoot a ray from my palm and see where I hit. And if it doesn't hit, then fall back to the raycast. Hi, Bevent. This is a Steam frame. Oh, yeah. Godot will be the fishing class? You mean as in Godot will be the example implementation to get people to get interested in your platform? That will work. It's definitely something where you wouldn't want to target just one game engine, where you would want to have the logic working on multiples. Okay. Yeah, let's see if we can do something about the logic of figuring out where to place it, because the first class. Yeah, that makes more sense. I don't know, a fishing class. Are we gonna go fishing? That might be a good little game to make as well, a little fishing game. So yeah, I'm currently only interested in just the placement of the hand. I'm not yet interested in getting my fingers to do things. So I am guessing. Okay, where is that logic? What do I do with that? That's just getting the closest grab point. So that's if I have one. Changes the shape cast. Yeah, so originally I was thinking about doing a shape cast. However, when we're looking at our physics direct shape, would that then be intersect shape? Checks the intersection of a shape given through physics degree purpose 3D object against the space. The intersected shapes are returned in an array containing dictionaries of the following fields. What do we collide with? What's collider ID? Shape. The problem is, and this is indeed the thing that I got stuck on before, it doesn't tell me where it collides. And that's the thing that I want to know. Because we're not actually physically colliding, we're doing an area check. Because, with our intersect ray, we actually obviously get where we're hitting something. And again, with the intersection point, which is also not what I want to use, we are not. Checks the intersection of shape given through that against a space if it collides with more than one shape. Here we do have an intersection point. So do I need to do get rest info instead? That might work. Normal and point. Those are the two that I need. Checks the intersection of a shape. And if it collects with more than one, the nearest one is selected. Well, we already know. Oh, that's actually a good one. All right. Because we do the get closest of this. Huh. Huh. Do we don't even care about having a detection area? This could be interesting. Ooh. Huh. Heck yeah. All right, before we do anything else, I am quickly going to go over here. And all right, so get back out -B, improve grab orientation. Actually, no, improve two-handed. Okay, if add dot, it net -M, improve, sorry, make an open source Godot coding model. I didn't mean an open source coding model. What do you mean with that by that, Bailey? Sorry, I'm concentrating on this, so I'm sorry if I'm not reacting very quickly to what you're saying in chat. Improve our two-handed logic. Okay. Status, get push origin. I just want to make sure that I have this nicely captured. Hold on, I'm just on another screen. I'm just going to quickly raise a PR for the work that we've done so far. PR improves a number of things in our two-handed logic. Notes, work done on stream 27 to 26 for anyone. More detail. Two-handed picked up objects. Now, rotates on the hands axes. What a moment. Sorry, I'm just doing this really quickly. Okay, so that is there we go. Added behavior. Now to make edits on primary optional. And we want to add in here softened the movement when the second hand. Let's go. All right. That's for me. That is an enhancement. Dick and Massa. Great. All righty. Sorry, I just did that behind the scenes a bit. I just wanted to safeguard all that. Run code, fine tune on Godot, example projects about to start working. All right. Well, yeah, you know, the more things we have for people to learn from and to get ideas from, the better. So now I can check out a new one for the rest of our logic. So here we're going to, what are we working on again? Oh yeah, improve pickup. Placements. Cool. Because we're about to do some really destructive changes. All right. I kind of want to say yes to that one. Yeah, everybody wants more adoption of open source, but you know, it is happening. People are starting to take notice of more open source software and getting much more friendly attitudes to it. But in the end, people need to decide for themselves what is better. But I do agree, the more examples that are out there, the easier it is for people to make those decisions. All right. So I am actually going to get rid of this area. And with that, we are getting rid of the whole detection thing because we're going to start using, and I might need to undo this. I might be getting a little bit more crazy. Okay, so the update enable, we actually don't care about. Update collision map, we don't care about that anymore. And we don't care about that anymore. I guess we don't have any of those left because we're going to do a cast. And that will allow us to do. So we don't care about this. We obviously are going to check our enabled. We don't need to update our collision mask. We just keep that in mind. We don't need to update our detection radius. And we're not going to do this, but we are going to go do this because that is... Huh. Hold on, there is something missing here. Yeah. Blah, 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 blah. Uh-huh. Update detection. Oh, because we completely removed that. So we do want this to stay there. I was a little bit too eager there. So here we're going to say if is no. Go ahead. I'm thinking about the wrong thing. Inside tree. I'm going to go do that. Oh, and I deleted that really nicely. Okay, so if let's get that. Save. If okay, I want to go get this back. And here we go. See, I was way too quick with this. We're going to remove some minuses. Yeah, of course we do. Minus. There we go. Oh. Oh. Bye. We just really. Sometimes. Okay, so. All right. No, we're not going to do that. No, we're not going to do that. No, we're not going to do that. We don't have these anymore. We do have our. Oh yeah, because we're doing that here. Let's keep that in there just in case I ever do something. Because right now, this is not doing anything in runtime. It's only doing something in the editor. That's fine. We don't really care about that. All right. So, time to start making things work differently. We're going to start with so here, obviously, we're just going to say if not enabled, we're not going to get a closest object. Yes, we definitely have ARM binaries. So we build both 32-bit and 64-bit ARM binaries, I think. So obviously, you know, Android uses ARM binaries, but we also have them for Linux. So yeah, definitely can have that working. All right, so now we're gonna do get res. So var results dictionary is state dot get rest info parameters. Now rest query, I'm going to call that. All right, var rest query. That now needs to be it's this one. All right, there we go. Now yeah, for development as well. I think yeah, and then all downloads. There should be. Where's the other ones? Well, we got a Windows ARM 64 build. I know that much, but we should have a Linux one too. Where's the? I thought we built much more. Is it filtering because I'm on Windows here? I want everything. Let's see below. Oh, because I'm selected on Windows here, maybe? Thanks. Oh yeah, so I need to then go to Linux. So here we have our Linux ARM 64 builds. A little bit annoying that you select the platform here and then it changes your downloads. Look, I would say that this should be higher, but I kind of get that we do it this way because we auto detect the platform that you're on and you're not bothered with the other ones. But anyway, yeah, so for Android, Linux, and Windows, you can find your ARM downloads right there. And they're full editors, so you can just use them. All right. All right. So, and one thing is, we want to create a shape here. So that's the one thing where I went maybe a little bit overboard in how quickly I removed all this. Because we do, I just want to call this differently anyway, so that's fine. Well, again, I don't know if that is a conscious choice. I can see that we might not want to confuse users when they come to the page and they're just looking for the download for their platform. So I'm not sure if it's done on purpose, but if you're looking for a different platform, it's a little confusing. So the question then is, which one has priority? Which is the more important one? Okay, so all right. Var detection shape, sphere shape. There we go. Let's go back here. And what we're going to do here is if not, so the very first time that we run this, we are creating our sphere shape. Okay. And now we set our radius to our detection radius. There we go. Cool. All right. So that is default. That is used. Collision mask. So we're going to do rest dot collision mask is collision mask. All right. Exclude. We want to exclude ourselves. Dot exclude. Did we? How are we excluding our own hand? That's interesting. Huh. That's probably because we are doing the ignore here. This is actually also going to be interesting, is that we're ignoring some of these. Yeah, because now we're always going to find the closest, regardless. Because that's the way that the guest rest info works. Is that going to cause us problems? I don't know. So that was a array rid. Yep. Or I want to put that a bit earlier. Let's actually do the state first. I think that makes sense. A bit pedantic, but exclude is nope, array rid. Okay, now for parents, yeah, parents, while parents I gotta just type that again. So we're just gonna go through all our ancestors. If parent is physics 23, we're not really caring about what types they are. That means that we can never pick up the 4, which is actually a good thing, seeing we're always going to be, well, no, that doesn't necessarily have to be a parent node. It could be a sibling node. So, so in this case, we're going to do exclude dot push back parents dot get rid. I think that is the one, isn't it? Okay, it might even be a collision object. Get rid. Okay, so is I think that's even better. So if any of our parents are collision objects, we're going to exclude them from our tests. And this at least ensures that we're not going to find our hand, we're not going to find our player body, I hope, I think. Yeah, I think that's always going to be apparent. Yeah, I know, you don't have this. I wish that it was smart enough that it knew I'm still working on this thing. Because I don't want to delete this until we're ready. Anyway. So what else do we want to do? Just let it fill up the log, whatever. Margin, we don't care about. We don't care about motion. We do care about shape. We can just keep that as a resource. So rest query dot shape is detection shape. All right. Let's close a few things. It's getting a little busy. Transform. Okay, so that is our offset. So all that we want to do. Okay, rest query dot transform is global transform times transform 3D bases, comma the grab. No, it's not grab offset. It's something else. Manual detection offset. That's what I was looking for. All right. So now we're going to go and test our results. Sweet. If not result or result is empty, there are null. We haven't found anything. Cool. All right. So now are you serious? Every other one, we nicely get the collider objects. Every one of them. Every one of them. Except rest info, we only get the collider ID. And we need the collider object. I publish some of my stuff on itch, but most of it is just on GitHub. So this whole project is on GitHub. Seriously, why does rest info not return the collider? I really hope that's just a... All right, so we've broken it right now. We can't pick something up, but I want to see what results gives back. That's just so dumb. Oh, what's happening now? Oh, we're going into... might actually want to cache that as well. I think I might actually cache the query. All right. Oh, what's happening to that? I don't know if you guys can see, but that's funky. Why is that suddenly happening? I don't know. What are... All right. Yeah. How fucking dumb is that? You guys can't see this until I do this. Oh, actually, you might have seen it in the background, but oh, and you guys couldn't see that the the chain was suddenly dancing. It's really hard to put the screen on. Actually, let's see if I can quickly do something about this. Run window. Keyboard height, keyboard width, mode window, yeah. Initial position. Okay. That is 0, 0. Absolute. And what resolution am I running? Display settings. 133440. Don't do that. 3440 minus 1920. All right. And this one, I'm actually going to move down a bit. All right, let's just see what happens. It ignores it. Really? Why are you ignoring this? That used to work. Once upon a time, that used to work. And well, I'm not going to bother with that right now. That's just a distraction. So. Okay. That's query. Okay. Are we going to assume that this never changes? Definitely this never changes. Will you stop plopping stuff up when I don't need them? Yeah. Okay. Okay, so those all are in theory changeable. So we'll set them. I don't know how much overhead there is in always recreating that, but you know, whatever. However, yeah. Oh, it's now undone this. So how are we going to find the collision object from the collision ID? Why isn't it just returning the collision object? Every other query of thing in here returns the collider, except the one that actually gives us the information that we want. How the heck are we going to solve this? You know, one thing that we could do is still have the area node and look up in everything that's within the area node whether we can find our object. How dumb is this? How bloody dumb is this? I can kind of get it, you know, in the sense that finding the object is tricky. Ow. Okay. What was I doing here? So if I then get there, okay, so we definitely need to redo that. All right, so we're going to reinstate the one can actually reuse that, which is kind of cool. Don't care about that. I just care about this. Okay. Let's see. I'm sorry. I'm flabbergasted by this, guys. This is just unbelievable. Okay. So. Let's put this back. Okay. I can do that simpler. Actually, let's put the question back in. God, this is annoying. Actually, I don't care about this. I just care about don't monitor anymore, because that should just turn all the logic off. That should be enough. Okay, and that should then also be called from ready, I think. Okay. All right. So, yeah, let's update the collision mask. There you go. Okay. Ready. Nice, thank you. Okay. We'll do that in a sec. Actually, let's do that first. No, let's do this one first. Mask. Okay. Alrighty. Okay. We just need to do this one. This is the only one that I didn't make a nice update function for. Whatever. Yeah, let's put that in there. Okay. Save. Let's rerun our diff because we moved where that is. What? That's not good. Okay, let's move that into the right place then. So that obviously needs to be after our private variables. Okay. All right. So change that. It still thinks it's in the wrong place. It's after our public functions. Really? Come on. Oh, that actually makes sense. Now, you know what? Wink. Okay. Wink. All right. Seeing it's complaining about those. Don't need you. Don't need you. Sorry. Okay. Save. How about now? All right. Right before private variables, we're missing a new line. Whatever. Just want to limit. Oh, here we go. Enabled. We still haven't got one. Just enabled limit the diff so that we don't get any craziness. So that I'm happy with. That I'm happy with shows us that we're changing the logic here. Here we're not doing the collision shape. That's fine. That does need to be in there. Okay, there we go. You know, this is where I really like using Git. Is we removed a whole bunch of code because we thought we didn't need it, and then we find out, oh, we do need it, and we can just use Git to get it back. Because I don't want to undo all the other changes that we've done. I just want to get back some logic that we removed. So this is going to be in our ready function. Okay, that's going to be slightly different. Ready, ready, ready. Where is our ready function? Here we go. And this is after that. Okay, before that. All right, so this is so done. Everything we need is in, what was it called? Get rest info. Get rest info. Set our collision object. So we use purely so we can look up our lighting objects. Yay. Boom. Boom. Okay. Var collision shape. This one we don't need to track. We never needed to track that to begin with. As long as an area is disabled, we don't actually, or as long as an area is not monitoring, we actually don't need our collision shape there. Or we don't need to disable our collision shape. That's what I mean to say. Okay. All right. Did I do the wrong one? Collision sphere. Did I? Oh, yeah, because I'm actually want to reuse our detection shape here. You know what? Yeah, detection area, detection shape. Yeah, whatever. Okay, so we're just going to do that. Okay, so here, this one, we shall move here. Okay. And then as this one, we do, oops, detection shape. Okay, cool. Detection area, we add that in. Sweet. And that we create that early here, that's fine because we're now going to reuse that. So with that, what we can do is, okay, we now know that that's going to be existing. So if that doesn't exist, we're going to panic because we expect that to exist. We're going to set our radius. Cool. We don't have a REST query. We're going to create it the first time. We could, I guess, create that in our ready function. Yeah, why not? Detection shape. Create our I'm going to call that detection query. Let's do that. Let's rename that to detection query. That's just, keep consistent in naming. Detection area, detection shape, detection query. Okay. Then obviously here, we are now going to say return. Well, it's better safe than sorry. If we don't have the things that we need, now we can trust that we do. This one is a little bit like, you know what? Can we? No, because enter tree happens before ready. Have we got any tree in here? Yes, we do. Yes, we do. Yay. Okay, so you know what? Nah, we'll leave that in what we're doing here. So I'm going to put a little mark here. Should we move making our exclude array into directory, or is this overkill? I am going to give that some more thought. All right. So we're building our exclude area. We're putting it into our detection query. Da 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 da. Oh, okay. This is the dumb thing. Let's find what we are colliding with, because can you see how frustrated I am with this? Is the okay for collider for body in detection area gets overlapping bodies if body dot get no 3. Okay. If body is collision object and body dot get rid is actually var collider ID. That should be a rid. Okay. Yeah. We found it. Collider is body. I guess we can do that. Break. All right. If not collider, return null. We didn't find anything. All right. So all right, we're gonna add some stuff up front here, but for now, boom, 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 boom. Var closest object. We're gonna return that. Okay. We don't care about you. That is going to become lighter. We actually do that on physics body. Yep, I know. We don't have the grab point yet. We're about to do that. So it's like this. So if for some reason we don't even have what we need, then cool. So now because we're only going to do it on the closest object anyway. Okay, so closest, the lighter, if grab points, where's by coming from? I don't know. In this case, we're doing return null. By. What is by? By. Yeah, we just did I. Oh, what? Huh? Oh, okay. So we're first checking if it's already picked up. All right, okay. I'm kind of not liking the fact that the old logic, if we can't pick up the closest object, we go to the second closest object, and we're kind of losing that ability. Okay, we've already up. Get our grab points, if any. All right, so in theory, with these changes, everything should work, but we're not any further along. We've now replaced our area detection with using the get rests, and then using our area detection to find the collider objects. But now that we have this, our query result gives us our point and normal. So we're going to add that logic into our closest object in a minute. So we don't do a distance on this, okay? So yeah, we're not really caring about any of this logic, whether we can or can't. I think that's just something we're going to go. So we've actually is any of our child objects, we're also ignoring it. Any of our parents, any of our children. Will we ever have a child of? I don't think I'm worried about that right now. Oh, this is from the XR origin itself. Anything within that. So yeah, that's probably then a good reason to make this something we do in our enter tree. Yeah, sorry. Oh, okay. Yeah, so I do want to. Okay. So, push. So let's start with moving this. Did that on purpose, don't worry. And exclude. There we go. Exclude. 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 All right. All right, so get rid of that. And the tree. I'm actually going to make a separate function for that. No, I do need to, but not here. Exclude any parents. Division parents of our node. One thing that could be cool is if we just go here and exit tree and say, let's go clear it out. All right, so we're going to clear it out. We're going to build that, but then here, we're going to go and exclude children. Counts 3D pass. Exclude any collision children. Now. Yep. Right. Actually, this is going to be called parent. Child and parent of children. Okay. Let's walk down the tree. And here we're going to say if child is collision objects 3D. Let's just go and steal that. And it's going to be you. Now, there's a good chance that we get a few duplicate rids, but I don't think that's really a big problem. At least I assume not. But that should work. All right. Let's see how much we've broken and whether we can still pick up stuff or not. But we should always be... Okay. Are you still working? Ah, I guess not. What? Type int of variable rid. How the hell do I translate a collider ID? So that works differently. So there has to be a function to get the collider from the collider ID. That has to be a lookup. All right. Godot, how to get a collider from a collider ID. You got to be kidding me. There is actually a function for that. Ugh. Well, I'm actually glad about that because, yes, it means that I've put everything back in place for nothing. All right. So my frustration is possibly completely wrong. Ah. Okay. Okay, well, hey, I'm actually kind of glad because if I thought that was a rid that it was returning, but if that's some sort of ID and we can easily get that back, then, you know, it just works. He learned something new today. Oh, you guys couldn't see this. You guys couldn't see it working. I hate that it doesn't open up or I tell it to open up. So, yeah, no, like I said, I can just, you know, hello. Works. Works. Oh, I'm getting some tracking issues at the moment. Cool. All right, so all that frustration for nothing. We can just get the collider from this, which means we can undo all the changes that we just did. Okay, so don't care about you. We don't care about you. We do care about you. We do not care about you. And that's in the wrong place. Oh, that's really interesting. But I actually don't care about you either. I don't care about you. I do care about you. I no longer care about you. I no longer care about you. I do not care about you. I do not care about you. I do not care about you. And I don't care about you. Okay. However, what I do care about right now. Oh, no, I'm doing it here. I did not remove that line of code. How cool is that? Okay. So, good news there, guys. I had a meltdown for nothing. All right, let's see if with these changes, I have now made this work. All righty. Yeah, there's something going wrong with this one all of a sudden. I do not believe I've changed any code here. And suddenly it is doing weird stuff. Why? Why are you doing this to me? Why are you doing this? I'm not going to be bothered by that right now. That has nothing to do with the work that we're doing today. That must be something else that is going wrong. This is all still working. We can pick up objects. It's happy. Cool. Now for the actual change that. Now, the thing is, even just replacing this has already made it so that we are miles ahead of where we were, simply because we are now getting way more info than we were getting before. Now, there is a potential that we might want to have a little bit more logic in here. And again, I'm kind of not happy about the fact that we are now always detecting the closest body. And then if we can't pick that up, but we can pick up something else that's close to our hand. Although there's also a part of me that actually likes this, especially because we have such a small detection radius. Because if the closest object to us is something that is disabled, getting another object might actually be the bit that gets us frustrated. Anyway, I am going to get rid of this. We are still going to have that on the GitHub side, but now we're going to actually add our point and normal in there. So whatever. This code is getting too big. Where are we? Where are we? Where is that defined? Where's the closest object? Closest object. Here we go. So we have a body, we have a grab point, but we also want to say is collision points vector 3. And while we're here, let's go get rid of that. Let's go get rid of that. Get rid of that. I know this is all nitpicking, and I probably have lots of more places that I need to change this, but at least I've done it in a few. And var collision normal vector 3. All right. So now so closest dots, that is going to become results dots no points and normal. This is going to be points. And this is going to be normal. Okay, and now we're going to do our funky. We are going to add something. Just for testing. Oh, we shouldn't have removed our vector before. All right, so we got a vector again. Top level. Top level. This time, let's just do visible as false. Again, we need to clean it up because it's on tests. And here we're going to go say vector true. And then vector dot transform is going to be transform 3D basis dot looking at result normal. Yep. Result points. So we're going to place our vector where our collision is on the normal. I'm not going to do anything with it yet, but we're just going to make that visible. Just to see what it does. All right. So as I come close, oh, that is. Oh, our normal is the opposite direction of what I'm expecting it to be. That's interesting. But it is doing what I expected to do. But that's also then why that's going inside. So is it a bug that is going the wrong way? I don't know. But we have it. So is it a bug? Okay, let's try it again, shall we? And see if that now makes more sense. Hey, we are trying to make a whole bunch of improvements to our pickup logic. So we just did a whole bunch of work on two-handed pickups. So if we pick this up and we pick this up, you can see that I am holding that with two hands now, and it's nicely positioning it and stuff like that. But I've also have with these cubes, I've made it differently that I can. Oh no, I turned that off. There's another mode where it always stays on the first hand that you pick it up with. So yeah. Oh, and of course I was actually trying to test if the normal now, but no, the normal is still. Is that something weird with the looking at them? That makes no sense. No, it's still pointing inwards. Fine. Did I not save my changes? Because I inverted the normal now, so a bunch of debugger issues here. That tell me anything? Target and up vector scroll linear. Okay, so that's something that I can understand. Clear. Now we can do something about that. You can say if ha ha ha. Yeah, let's go replace that with that. And I don't care about that really. Okay, so what we now want to do is come on, give me some space. There we go. And again, this is only test logic, so we're doing way overkill. Vector 3 up. Oh, vector vector 3 dot up dots closest smaller than 0.9. You do that. Else vector 3 dots left. Doesn't really matter because it just rotates around the center line. All right, let's see if that now works the way that I expect it to. All righty. Well, let me guess, something broke. What are you? Oh, idiot. Yeah, that wouldn't work, of course. All righty. Well, why is this all of a sudden going completely berserk? Okay, that's not working. That's not working. That's not working. Yeah, cool. Sweet. All right, so now, cats, what are you doing? Yeah, that's cool. That is so cool. All right. Okay. All right. So I'm going to get rid of this testing stuff because we now know that how it works. What you doing, cat? You got food in the kitchen. You got food in the kitchen. Meow. Meow. You want a snack? You want a snack? Here you go. Thank you. There you go. Cat cam. I should have a proper cat cam. Okie dokie. So, remove my test thingy. Prove that it works. It's actually that worked way better than I expected. So yeah, no idea why that is inverse. Actually, I don't care about that question. I think it is actually pretty, pretty. What's the right word? Yeah, pretty solid. I think the collision normal is in the direction from the collision shape, not the collider. So inverting is exactly what we need. So now that we have that, we have closest. Now we need to go and look at our logic. So in our rigid box, crash. Okay. Haven't had one of those today. Hopefully didn't lose anything. Oh, I think we were there. Oh, not quite sure what happened there, but whatever. Oh yeah, that's right. We fixed that in something later. Oh yeah, so closest grab point is if we have a grab. Oh yes, that's what I wanted to go there for. So I'm going to disable my 2 grab points. So if the grab point is disabled, we are just going to position our hands according to our grab logic. Now, the downside is that disables the posing. And I'm not going to worry about the posing right now. I'm purely going to worry about the placement. All right, so if we have a grab point, now this is just getting our closer, so we already have our grab point. So let's go to where we're doing this. So we're calling that from here. So if we have a grab point, in which function are we right now? Picked up object. Yep, cool. Other. Okay, so this actually needs to change how this works. So if we have a grab point, we do that. If we don't have a grab point, we're going to get default hand transform. And the thing is that this is just doing our alt breakcast logic. The thing is that we don't have that anymore. And I guess we need to keep that as a backup. I'm going to take that out. MI. So, pick up objects. All right. We're going to change that. We're going to change this to being closest objects. All right. Now, this is going to become closest objects. But we're going to go and rename that because that is now a really bad name. So let's start with that. Restoring. So we're going to actually rename this to grab objects. Restoring object info for grabbing. It's going to be that. It's going to be that. It's going to be that. Maybe that. Maybe that. Maybe that. Cool. Okay. So grab objects. Body. Okay. I'm not going to call this rich anymore. I'm going to say objects. Objects dot body. 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 Maybe that's not the best name, but okay, I think that does that. But now, in here, what we can do is actually go and do this. Instead, what we're going to do is grab transform is transform 3D. Okay, so this one should be so that is the grab points. If we look at our rigid body, that is where our metacarpal is. So eventually we do want to have a offset in there, because if we show the hand here, we see that, you know, we're going to take that as a grab point, and we're now putting that on wherever our collision is. So we actually want to have an offset from our collision to that, where our collision would be the palm of our hand. So that's definitely something that we need to do, but one step at a time. I'm actually going to put a remark here. We need offsets here. As our position point should be at. Okay, but the other thing is, what I actually wanted to look at this is rise up. Okay. We're actually going to make a helper function for this. Yep. This is going to be gets and transform from the service. And here we're going to say objects dot collision points and object dot collision normal. And obviously we're going to want to put that remark somewhere else, but let's go first to I don't want to remove that alt function yet, even though we're going to retire it. Points vector 3 normal. Okay, transform 3D. Bar transform. T. Transform 3D. Okay. Now, you still need to apply. Okay. So we're going to start with saying T. You can actually do it here. T is transform. No, look that separately. Because we're going to do that same thing that we did a minute ago. Vector 3 dot. Is that smart? Huh. No, we need to do this. We can do that based on our pickup. because we want to keep the orientation for the hand the same. So we're going to use the transform of our actual pickup. All right. All right. So when we look at this, that's the vector that we have. So that's going to be our Z vector. So that's a given. But now we want to have that vector and that vector based on our actual hand right now. So what we're going to do is we're going to take the Y of our actual hand. Are we? Or do we need to do it from the picked up object perspective? No, we're gonna do it like this. Let's just see if it works. I might get this wrong, but let's just see if this works. So, t.origin point. That's it. That's a given. All right. T dot bases dot z is our normal. Okay. T dot bases dot x is going to be global bases dot y cross normal. Might need to be the other way around. Actually, t let's see. Analyze. I want to make sure that that's in there as well. And then t dot bases dot y is going to be t dot bases dot x cross t dot bases dot z. All right. All right. So it's going to be positioned wrong because we still need to do our offsets. But this is going to be our starting point. Now, it could be that I'm now inverting stuff, because I always forget which way to cross. All right. Huh. Interesting. Yeah, that's going to go wrong, of course. Oh, that was definitely not happy. Okay, that's really interesting. Why are you not resetting? That's really weird. Because, okay, I get that we're obviously doing the offset wrong, but it's not returning that back to null. That is too weird. Okay. Am I doing something more around here? All right, let's see. We don't have the finger poses, that's right. If we have a grab point, we're getting the grab point here. And using all that, we're going to apply our target off override. Underscore grab offsets, which we are calculating here. Double grab transform. And that should be undone when I let go. So why it's still showing that wrong, I'm not sure. And also with the collision point in the right place. Because even if I don't do this wrong, it should be in the right place. Let's see if I don't orient this, whether it then does something suitable, whether the positioning is good at this point. Okay. All right, that's because the box turns around. Because obviously I've done it like this. Is it? Yeah, because that's where I picked it up, but I didn't orient it right. Okay, so that makes sense. Okay. So I'm guessing that because it didn't cross it right. Okay, let's flip this around. And this is really trial and error at this point. This is always trial and error. Okay, so I'm going to do X as that way around. Oh, you guys might not have seen what I was just doing. Sorry about that. I really hate that even though I've set it up, it does not put it in the right place. It's so annoying. All right, let's try again now. So, no, definitely completely still wrong. All right, let's flip the other one around as well then. And again, it is possible that I am making well, at least it's not going upside down again, but it's definitely all right. Oh, idiot. That is X. I am right now centering on Y. And watch this logic needing to be, okay, so X is going to be Z by that. Y is going to be Z by X. So this is going to be X. This is going to be Z. Now I am going to, well, I'm going to try this first, but I think this one now needs to be the other way around. Okay, let's have a look. Okay. Monkey. Oh, you guys couldn't see that. It was upside down. But it wasn't inverted. And this is the other thing. With the left hand, it's actually opposite to the right hand. Which is really, really weird. Is that something that I'm doing? No. All right. If we go to hands, inherent, bone attachment. Quickly check something before I forget. Oh yeah, damn, we've got XR meeting coming up tonight. Should not forget about that. I need to finish this soon. Okay. That's the one that we're using. Oh, okay, that's right. I'm not quite sure what the reasoning behind that was again, but right. Well, I am taking that into account here, so that should work. However, let's say that means for left hand it is pointing inwards, and for right hand it is pointing outwards. So, all right, let me try this one more time because well, let's go and hide this again. The other thing that I really want to do right now. I'm thinking about visualizing this. All right, let's just do that as well. So on this one, I want to put an axis. I'm going to do the same thing as before. Is make that top level. Make that top level. And I want to finger this. We can just say axes dot transform is T. Okay, let's just see what that looks like. Yeah, hello. All right, 20 in the front. Okay. Why is X down? Why is X down when why? Why is X down? I'm just going to do it just for right. Vector dot transform is transform 3D. This is stop looking at normal. Right, it's good enough for me. I think right needs to be. Oh, why are you still running? All right, so I just want to see if that vector is indeed the wrong way somehow, even though everything was working before. So, oh, I forgot to make that top level. Of course I did. And of course I forgot that too. Transform top level. Save. Project settings. Okay, I'm just going to have one more look at this. Yeah, I've got an absolute position. Why the bloody hell are you not listening to that? Sizable. Yeah, that's all fine. There may be something in editor settings that I need to do. Window, oh. Really? 3440 minus 920. Close. Play. It's in the right position. Woof. Okay. So we were just setting that in the wrong place. Yay. Oh, that's actually kind of good. All right. So let's go and have a look. We're going to go and grab you. So notice our vector is pointing up as we're expecting, but our axis pointing down. What the heck? We're going to have a little bit of fun here because I know that I have a call that label. Okay, that label is. Let's just verify whether there's something that we're getting wrong about that. Normal.x, normal.y, normal.z. Okay, so just all this time it's the looking at that is wrong. So when we were placing our vector on top of our cube, that's because the looking at function has that bloody dumb that you can invert it. So normal, right, comma, true. Okay, and while we're at it, that means that our whole thing that we were talking about the normal, now makes sense. Where's our get closest object? No, get closest. So the whole thing around that was that we were just displaying it wrong. Idiot. And that means that we probably had some other things wrong while we were doing it. We were thinking that the vector was pointing the wrong way, because remember with our hands, our vector was always pointing backwards. It was actually pointing the right way. Our look at function was wrong. I need to make a nice helper function on that vector class. I think I'm going to do that right away. So you can see that that now fits. That's actually in the right position now. Boom. Boom. This is going to go wrong. Well, except that it crashes. Why? No. What? Oh, because I didn't put the vector on that. I knew that was going to go wrong one of these says. Okay, let's put that there so that we at least have it, so we can visualize what we're doing. And then in a minute, we are going to deal with that. But for now, I actually want to go onto my vector class. And I actually want to create a helper function here. Where is my vector class? It's a debug class. Here we go. Vector. There we go. Func. No. Please. Vector at vector direction. Not point 3D. Why am I saying? I'll fix that in a minute. I just want to get that in there first. Okay. Vector 3. Right. However, we're going to make that a little bit better in a minute. So that's going to be direction. That's going to be at. And what we're going to do here is if absolute vector 3 dot up dot at smaller than 0.9 else. Really? So that means point. Oh, that's going to be making our lives a lot better. We are hopefully not going to make that mistake again. Right. So, perfect. Yep. Yep. So that was what I was expecting, because our left hand, we actually need to rotate it. So, all right. Do I already have something that makes it easy for me to see if we're on the left hand or not? Let me actually go and search. Is there anything here? Oh, look at that. Is left hand. That's exactly what I was looking for. Yay. Right. There. Okay. Right. Let's see if that makes that bit better. Now, obviously, we're also going to go and get a different offset for that. Huh? This is our right hand, and we're now inverting on our right hand, really? Okay, hold on. All right. Huh? How did that not error? How did we not get an error about that? Oh, because it is valid to check if we have the is left hand function that way. Okay. Let's see. Oh, yay. Oh, and I forgot to make that local. Okay. Other hand. Two hands. All right. That is working. That is okay. So one thing that I want to try now is, what if we are facing the other way? Still working. Still working. That is cool. Okay, so now so now we need to make the offset work. Okay. All right. So, we're gonna get rid of these two. Get rid of these two. You anymore? We know not at your work. We know not at your work. Okay, so now what we want to do? Let's go abuse these since we have them. Just hide the box for a sec. Let's go and show the hand. plus 3D. I'm just going to use this hand as a reference point. All right. Okay. Actually, huh. Hey Wes, how you going? I suddenly realized that we have that offset already. I'm trying to grab some stuff and figure out a natural place to do the grabbing. So, cool. All right. So the thing that I suddenly realize is in the pickup, we have our detection offset. Now, that one is there. So, 0.3 minus 0.3. Okay. Oh, okay, because that's always in the same. We were looking at the circle. But I can't really see where the center properly is. And I think I have... Yeah, I didn't do the X offset there. Only did the Z offset. However, I think that is actually something that we can deal with. Ha! I haven't done Pokemon for a while, but Blake always was very enthusiastic about it. Right. All right, we're going to do the detection offset. We're going to actually use that. I think I need to subtract it, but I could be wrong. Might need to add it. Right. Okay. So this is going to be T is T times transform 3D basis minus detection offset. I think it's minus. Could be wrong. But it does mean that I actually want to make something more to make the Jesus, what's wrong with my internet all of a sudden? Okay, so. Yeah, I think that's close enough, I think. Yeah, like that. So obviously we are still having positioning things. Okay, so that's really cool. So that's really working. Now let's see if with all this work, it still works if we turn off hand tracking. So actually I want this censored on primary 0, because that's, yeah, project settings, that's being overlooked. So I want to go back to OpenXR. I'll turn off hand tracking. I just want to double check if, because this is completely different. Well, Blake's been a bit sick today, but other than that, he's pretty good. But he's starting his motorsports program tomorrow if all goes well. So that's going to be interesting. The crown number 2 mean? I have no idea, to be honest. That's a YouTube thing. All right. Yeah, that still works. That all works. Interestingly enough, that does do an interesting sort of offset. This is really cool. I'm really happy with this. All right, so one last thing that I want to do, and that's just a debugging thing, is, and again, that's another thing that at some point with these, with the grab points, sorry, no, with the pickups, I am going to need to, I'm going to need to do something to allow it to make it easy to do this detection offset and change that so that we actually have some gizmos here. I really need to look into gizmos. We got ourselves a GT86. All right, so let's do this thing last, and then it's time for dinner for me. So. Actually, detection videos. Okay, okay. Okay, we're just going to do that one. And then we're going to say, oops. And then we're going to say scale is vector 3. Okay. Probably need to reopen that before that takes effect. Okay. So just for now, that's just enough to at least see what our center position is. Now, I do think when I look at that, you will probably want to put that more into center of the palm like that. And if we look at our other hands, we might want to do that too. And gotta hiccup it. Actually, let's put a remark here. For now, visualize our center, but it should be replaced by no. There we go. I'll send you a photo after I finish streaming this. It's pretty damn cool car. Let's move that to 6 as well. Right. So that's a nice little helper that we can at least see where our center palm is, and that's also where we're going to grab things. Now, one of the things is just fun, and I don't think I am going to solve this, but I still think it's fun. Is, I can pick that up, but I can do this, and then it obviously flips around, right? And that is because our detection is going all the way around. So one of the things that I probably want to do as an improvement at some point is that you can only grab things that are under the hand, not above the hand, by maybe doing some sort of check on the point. And then just, yeah, dealing with that. We can probably, actually, we can probably already, yeah, I think I can do that. I think I can do that. I think I have a very simple solve for that. Right, so get closest. What we can do over here is a result. So here we got our result. And what we can do in this case is say, can we? Can we? Yeah, I think we can. Oh. Yeah, if we take the x of that, that needs to be pointing, well, for the left hand, obviously, we're going to go the other way around. So here, what we're going to do, bar and normal, is global basis dot x. So in this case, we're going to do negative. And now we're going to say, in this case, we're not going to do absolute. We are going to say hand normal dot results dot, is that collision normal? No, just normal. All right. If that is smaller than 0, return null. Right. We'll look if that works. I think that will do everything that we need to do. So, pick up left hand, right hand, works. Pick up left hand, works. Pick up upside down, nope. We can also see that the thing it is, we need to now be at least, and we could even, you know, make that a smaller angle and say like, yeah, we actually want that to be, you know, less than, I don't know, half or 45 or something like that. Cool. Yeah, this is super cool. All right. Projects. Let's remember to turn this all back on. Blink, blink, blink. All right. All right, everybody. I'm going to leave it there. It is way past dinner time. I have a XR meeting to organize in about 2 hours. So I am really happy with the progress. This is super cool. Oh, 5 hours in total streaming. Bloody hell. All right. I hope you all enjoyed this. I hope it was interesting. Yeah, I had fun. Got a lot done, so I'm really happy about that. And yeah, let's leave it all there. Thank you all for watching. I hope you learned something. And till next time. See you all.